Hey everyone, thanks for joining. Today we're going to work on implementing Pong. So, classic game, probably everyone's seen. Also a great kind of first game to build. So let's dive on in. Alright, so first, just like always, I'm going to go clone me a fresh copy of my basic web template. You can snag a copy of this on GitHub if you want. Not great for proper development. I would pick something a little more established, but it's handy for playing around with. It's handy for our stuff. So I'm going to go ahead. If you're not familiar with GitHub, you can always download the zip, and then you don't have to even worry about what GitHub is right now. Or you can use the GitHub desktop, or you can just use command line, which I'm going to use. Oh, I'm going to store it. Git bash. Git clone. And we're making Pong today. We'll call it Pong. Alright. I should have a Pong folder. Perfect. Gonna go into WebStorm, which is my favorite IDE. We're gonna fire up that folder. And trust project. Alright, and then I'm just gonna run install real quick to get all the dependencies done. And while that's starting up, let's pop over to Photoshop. Now let's first just, kind of draw out what we're going to do today. Grab the tab here. Alright, so Pong. So we'll start out, we'll just implement kind of a fairly classic version of Pong. So we have our play field. We have one paddle over here. We have one paddle over here. And we have a ball. And just in case you aren't familiar with Pong, basically the ball will bounce off of the sides and go into one of the player's things, or if it hits the paddle, it'll bounce back off the paddle. And you can try to send it over to your opponent. And I guess we do have scores, don't we? And that's pretty much it. So Pong's pretty straightforward, at least conceptually. And of course, the paddles can move up and down. And that's about it. So let's go ahead real quick. We'll go ahead. So we have, so we'll have two paddles to build. So let's start out. We'll just kind of mark what things we need so we can kind of start planning those out. So paddles, there's two of them. They move up and down. We have the ball, bounces, and if it hits the end point, or if it hits one of the edges, edge, toward point, and if it hits a paddle, or the wall, then it bounces. And we have our score, which we just need to show and keep track of. And we'll also have, let's have a start screen. So the start screen will just say like Pong and the start button. And if you hit start, it goes to that. And then once we reach whatever the point total is, so why don't we say 10 points for now, we can always change that. We have the game over. Game over. And we would say like player 1 or player 2 wins, whoever won. Player 1 wins. And then we can have a play again button. And then if we click either of these buttons, we can go back there. Okay? And then, of course, we just have to draw each thing. So let's go ahead and we'll pop over to our code. Whoops. Pen on the tablet. Make my mouse go crazy. All right. So we've got our stuff installed here. I'm going to do npm run dev to get it going. I'm just going to spit out a bunch of stuff we can ignore. All right, listening on port 8000. So if we pop over to our browser, go to localhost 8000. Here's our game, and we can't see anything because there is nothing, but we can see it did load up our file, so we're good to go there. So, and if you're using this guy, just you can ignore everything other than the client folder you'll want, and then anything in public you'll want. So let's start out in our HTML file. So there's really two main ways you can create games in JavaScript. The first would be to use the DOM, use actual elements like buttons or images or whatever, move them around the screen directly. That works okay for some kinds of games, but it doesn't really let you have very nice fluid motion. So since we want nice fluid motion, we're going to go with option 2, which is to use a canvas. And a canvas, just like a paint canvas, is basically just a white square that we can throw whatever graphic stuff we want on, and it'll just show it. But we're responsible for whatever we draw on it, so we have to handle all that. So go ahead, we'll just make a canvas. So that'll be our space, and let's go ahead. We'll give it a. We want to give canvases have kind of two widths and heights. They have one which is their like display width, and they have one that's their internal one, and it's kind of like their rendered one. So if you think of like a regular video game, you know how you select the option for your resolution, and you may pick like 1920 by 1080 or whatever. But then you can actually still change the size of the window, but inside it's still rendering at 1920 by 1080. It's the same thing. So our width that we're setting here is the resolution one, that 1920 by 1080. And then we can still control the size, although in our case, it'll probably be the same as long as your monitor is large enough, which we're only going to do, let's go, 800 by 600. So that gives us a 4:3 resolution, which is kind of old school, but Pong is also kind of very old school, so good enough. And then if we refresh our page, we still won't see anything because the canvas is white on a white background. But if I mouse over here in my Elements tab, we can see where it's lighting up blue, so that's our canvas there. So let's go ahead. We'll slap in just a teensy bit of CSS. So I'm going to hit plus to get an inspector style sheet. And this lets me kind of edit the CSS on the fly. So I'm going to first just throw in a background. We'll do kind of like almost letterboxing. And then on my canvas, I'm going to give it a white background. That's red, white. And we'll go ahead, we'll center it. Needs to be display blocks. We'll move, there we go. And then we're also going to do, actually, you know what? Let's do absolute positioning. We'll do position absolute. We'll do top 50%, which puts it the top of the image 50% down from the top of the page. And then we're going to do left 50%. So same thing, just going this way. So it's the left edge is left 50% compared to the edge of what it's in. And then we're going to use transform, which lets us do various transformations. We're going to do translate, which is just a fancy word for move. We're going to move it back 50%, and these 50% are based on the width of the element. So these 3 lines give you a real easy, nice way to perfectly center something in the center of your screen. So there we go. And I think that's all the CSS we're going to do for this project. So I'm just going to pop this into index.css so it stays put, because this guy disappears every time I refresh the page. All right, there we go. Cool. So now let's go ahead. So we'll start at the beginning. So we'll work on this guy. So we need to render this guy. So we'll just have our screen, and then we basically just have some text, and we'll do a button. And that'll be our first step. We just get it to render. And not right with the mouse, which is what I have. All right. So we'll pop over to our index.js, and let's get started. So first, we just want to get a hold of the canvas. Const canvas, query selector, canvas. So this is just going to give me a reference to my canvas, and we can console log it and see that. So I can mouse over it here. So this is where it output my console log. I mouse over, yep, I got a hold of the canvas, I'm good to go. Then what we get is called the context. Context. And this is the rendering context. And you can actually, there's a couple different contexts. We're going to use 2D. It can actually do 3D as well. You do the WebGL context, but we're keeping it simple. We're doing 2D. 3D gets kind of crazy pretty quick. Okay, so this context is basically how we draw to the screen. So let's go ahead. We're going to draw just the word Pong to the screen to start with. So we'll do context. Oh, and just a note on this. So I called it context. A lot of times you'll see it CTX, and that's just a shortcut to context. But know that usually these guys are the same thing when you're talking about canvases. Yeah, we're going to do context dot draw or fill text rather. So for any shapes in the text, we have either a fill or a stroke, or you can use a fill and a stroke. So stroke is an outline, and then fill is filled in, just like the paint bucket in MS Paint that probably everyone's used when they're in class. Probably supposed to be paying attention, but paint's more fun because whatever you're doing might be a little slow right now. Okay, so we'll do fill text first to give it a text, so Pong. Then we give it the positioning. So when we position things on a computer screen, in 2D at least, we always position, so if you think this is your monitor right here, then this corner right here, so just like in math, well, just like in kind of math class, this direction is X and this direction is Y, except in this case, this point right here is 0, 0, and then as you increase it, we move to the right, and as you increase Y, we move down. So X is kind of what you're used to for, like if you're thinking like math class, drafting stuff. This direction is the same. Just remember that Y starts from the top and goes down. Pretty much everything on the computer starts from here and goes that direction. So if we want Pong to be smack in the middle, we're going to do kind of like we just positioned our canvas actually with CSS, except we're going to do the math ourselves. So we're going to position it right in the middle. So first, just like we did with the left, we're going to just put it in the middle of the canvas. So to get the middle of the canvas, we're going to want to grab the width, and we're going to want to grab the height. And a kind of fancy way you can write this is to use the destructuring syntax like this, which does exactly what this is with the width and height. It's just in one line. So we have the width and height. So we're going to do then width divided by 2. And we'll do for height, we're not going to put it in the center of the screen. We'll just, pick a number. Maybe let's start with 50. We'll probably need to play with it a bit. Let's see what that gives us. So really tiny font. So let's bump up our font first. So to bump up our font, we're going to do context dot font. Font. And then this is just like the font property in CSS, if you're familiar with that. So it is font size, and then it's font family, which is just the font itself. So we'll do a Arial Helvetica and sans serif. So when you do CSS, not everyone has all fonts in their computer. So this is what's called font stack, and so it's basically saying if you have this font in your computer, use this. If you don't, if you have this one, use this, and if you don't, use this. And this one in all lowercase is like a default. Everyone has some sans serif on their computer. All right, let's do that. Let's just crank up the size. There we go. And then you can see, just like when I did the canvas a little while ago, it's the left edge of it is at 50%. So we want to shove it back half the width of the text now. So to get the text, we can use context.measure text. We put in the text, and this is going to tell us our size. I'm trying to remember. I can't remember what. Let's see what NDM. There's a word that is commonly used with that. I can't remember. Oh, they just use text there. That's kind of good. Yeah, it is metrics. That's what I was thinking. Okay. Yeah, I don't like comments. Well, I guess that makes sense when you do text.width. All right. We'll just stick with metrics though. And then we're just going to get the width. There's actually a bunch of different values you can read or get that tells you different things about the height of the font, but we won't worry about those. For now, we're just going to do width. So, so metrics.width will give us half the width of this. And so if we want to shove it back half of this, we just divide that by 2. So we'll do width divide by 2, and to shove back would mean we go negative. So minus metrics.width. And then if we check that out, we should have it nice and centered along the x-axis. Okay. That's interesting. So if you did I not? Oh, I forgot to divide by 2. Well, that would explain it. There we go. All right, and let's crank it up just a little bit bigger because we only have the font or the text and one button. So we'll crank it up. We'll crank it way up. Let's go like 120. And why don't we do this in all caps too? And then let's drop this guy down. Maybe 150 maybe? Yeah, let's go a little over 200. And this is, and actually, we'll switch. I usually, by default, the baseline, the text baseline, which is where where values affecting the text height are relative to. By default, center. I usually like to use top when I'm positioning things just because then you're specifying basically how big is the gap instead of having to figure out the font. So there we go. We got Pong there. And we can go ahead. Why don't we'll slap bold on here. So stick that in there just to make it a little heavier. And let's go ahead, we'll make it a little prettier. Well, pretty relative, I guess, but we'll change the color of it anyways. We're going to do the fill style. And let's do 0080FF. That's the blue I like to use for things. And then we'll do the stroke style of maybe that's kind of a dark green. One thing nice about this ID is you can see the color right here, a nice preview of it. And so we're going to do fill text here, and then with the same exact everything, we're going to also call stroke text, and that will give us an outline around that. And we'll do make the stroke just a little stronger by doing line width, and we'll say maybe 5. And that's kind of pulling these numbers out there. There we go. That's okay. And we did, and notice I did the fill first and then the stroke because the stroke's drawn on top. If I flip these around, you'll notice, see how the stroke kind of got half as thick? Because the stroke is actually sticking out halfway beyond the edge of the actual word. But now we've drawn the fill on top, so we're covering half of it. So usually you want to do stroke on top of fill. Okay, and just I'm going to rearrange the code just a bit. I'm going to put grabbing the metrics up here, and we'll do the setting with style there. Okay, so there's that. And now for the button. So our button is going to be pretty much the same thing. So we'll start with the words. So we can just basically, yeah, let's just go ahead. We'll copy all of this just for simplicity's sake. We will not, let's not do a stroke for this because it's already going to be on the background for the button. We will, yeah, let's leave that for now. Cut the size down a bit. Let's make it not bold. And the wording is going to be start. And we're going to need to actually grab the metrics again. So we'll call this for now Pong metrics. And we'll call this one down here start metrics. we're going to clean this code up in just a bit, so we're not too worried about this right now. Always avoid worrying too much about getting everything right and your code perfect right from the start. You'll want to refactor your code as you go along. That way, because your code's always evolving, and something that code that looks organized now, when you add 10 more things to it, may not look organized. You may need to take another stab at it. So don't worry about getting things perfect right from the get-go. And then obviously I goofed on something because I'm shoved over. It's a little weird. I'm not sure what's up with that. Anyways, let's go ahead. Let's get this guy moved first. So the start is still good, or the width rather, the X. We still want the text centered. Our Y just needs to shove it down the page further so it's not next to it. Okay. That's kind of funny. I don't know exactly why it's doing that. One shoved over one way, the other shoved over the other way, and they're like perfectly in line. And it shouldn't do that. All right, let's shove it down a little more, and then we'll figure out the mystery of the weirdly centered thing. That's too far. All right, that's good. Okay, so let's go up here. All right, context, measure text, Pong. Oh, okay, let's do this real quick. I'm gonna I cut that, so I pulled off the page. Okay, so nothing here affected it. It's always good to just kind of check that out real quick. Okay, so we have our width, Pong metric width, divided by 2. That should be right. Oh. Let me go ahead and get rid of that real quick. And then this start metric. That's very weird. I don't know what because one thing we could do is a text baseline. So there's also, in addition to text baseline, there's a corresponding text line, which just like baseline is where the Y goes in the center. And actually, this is easier anyway, so we'll go ahead and switch to this. I kind of want to solve the mystery, but I don't want to spend a bunch of time spinning our wheels either. So we're going to align center. If we align center, then we don't even need this because the text is going to align center anyway. So we'll save the mystery for another time, and we'll just go with that for now. All right, so there we go. So now we're back to center. Yay. All right, and now let's put a background on our start. So for that, we're going to use context.fillRect, which is short for fill rectangle. And this takes an X and Y, which is the top left corner, because most stuff in the computer is top left, and then the width and height of the rectangle. So we will actually need our metrics back for our start. So go ahead and put that back, because we're going to need to know how wide it is so we can get the button around it properly. So context.measure text, start, and measure text to match, start. Okay, and then so we'll want it to start to the left of our text, and pad it out a bit. So let's try. So first, figure out what the right edge is. So our start text is here, and imagine there's an invisible box around it that like hugs it real close. So because we're center aligning it, this right here is the width of the canvas divided by 2. So this point right here is width divided by 2 minus the text width divided by 2. So that'll get us this corner. And then we're going to shove it back even a little further by, we'll say 20 pixels, just to try that. And that'll be our padding. So width divided by 2 first, then start metrics dot width divided by 2, and then back another 20. Okay, and because this line is going to get kind of long, I'm going to put each parameter on its own line to keep our code clear. Okay, and now as for the height, it's kind of the same deal, except right now, so our baseline is top. So right here is the line where this 400 is. So to shove it back, all we need to shove it back is some for padding. So we'll just say 20. So we'll just do 400 minus 20. Whoops, no way. 400 minus 20, which of course we could code it like that, or we'll just simplify it to 380. Then the width of it, so our width, if we want a box that's spaced out 20 around the whole thing, then our width would be the width of this guy plus 20 plus 20, so plus 40. So start metrics dot width plus 40. And then the height is similar. There's two ways we could do this. The super duper accurate way is to actually subtract one set of descending from another. You have a couple different ascendings, which you can do that. We're just going to kind of approximate it. So the font size is really close to the size, plus or minus some descenders, or ascenders, which are the parts that go below or above the line, like the little tail and G. But since we wrote it in all caps, we don't have any ascenders, so that means that the 60 is going to be almost exactly the height. So we're just going to say 60, and we'll cheat a bit. And then we need to add 40 to it, like the others, so plus or minus 100. And the fill rect is going to fill the current fill style. So we'll actually make the box blue, and let's make the font white. And you can see here, I call fill style 3 times, and it'll keep reusing fill style until I call a different fill style. So that means all of these lines are with it being blue, and then all of these lines are with it being white, and then this line will be blue again. So let's see what we've got now. Almost. Context.fill style white. Text. Oh, yeah. So I drew the rectangle after the text, which means the rectangle went smack on top of our text, and we couldn't see our text anymore. There we go. Okay, we are a little off, actually. A little more than I would like. Alright, maybe we'll measure it. So the start metrics dot, see if I can do this from memory. I think it's start metrics dot actual bounding box descent, which is the position under it, minus the ascent, which is the top point, and then we need to add that to the height of the text, which is 400. So 400 plus the height. No, that's wrong. This is just the height. All right, this is just the height, not the y. It may worse if I could not do this from memory. Alright, so let's do this real quick. Let output start metrics and look at what's inside of it. We can play with it a bit. So we have, alright, so our actual descent is 94 and our ascent is 6. Oh yeah, that's one thing I forgot. It's negative. So because it's actually from the like top of where we told it to put the text. So, and of course we subtracted those, so we ended up with 100. This is not right, because it should be closer to 60. Actually, none of these are, none of these numbers, if we did math with them, would actually give us anything close to 60. It's a little surprising. So, alright, so look real quick. Oh, you know what? It might be because we have the, yeah, the top, or the baseline set to top, and that could be causing these numbers to come up different than I thought. No, I'll just eyeball it for now. Normally you wouldn't be measuring stuff like, you wouldn't measure it like this anyways, because normally you would just use a graphic, whereas you're drawing it like this because it's faster. But we don't want to spend too much time on this. So, let's add 2 more pixels to the bottom and call that good, probably. Yeah. Okay, whoops. Alright, nope. Go away, tablet. Sorry, guys. There we go. Okay. Tablet on the floor, so I didn't it? Alright, so there we go. So now we got our stuff. So now we want, so that's one step down. We just have it rendered. So render yay. And then the next one, the next step we need is when we click our button, it should take us to the game. So let's get that one sorted now. So to handle clicks on a canvas, we basically handle them the same way we do anything. So we're going to add an event listener. So canvas.add event listener, add a click event, and then we're going to need our event object. And now the difference is we don't want to just clicking anywhere to work. We want to click on the actual button itself. So what we're going to want to do, console log event so we can see what we're playing with. Oh, I have to click. Oh, maybe it was console. Okay, refresh. Okay, so we got a pointer event, and we can see we have a couple X, Y's on here for different things. We want the client, no, we want the offset X and Y. So offset X and Y are where the offset is relative to the thing we just clicked on. So you can see I just clicked almost in the corner and got 4,4. And if I click over here, I'm going to get something that's almost 800 by 600, the width and height of our thing. Yeah, so I almost clicked in the dead center. So this tells us where we click. So what we're going to want to do is we're going to want to check for collision if we clicked on this box. So anytime we test if 2 things have hit one another, we call that a collision or collision check or a hit checker, whatever. So we'll need to then know where we put the, how big the button is in order to do that and where we put it. So we basically need to know this rectangle stuff here. So let's go ahead, let's clean up our code just a bit, and let's, we'll go ahead and we'll throw, first let's go ahead, we'll throw all the, and then let's throw all of the code for drawing this page into a function. So we'll call it render start screen. We'll go ahead and throw all this code in there. And then we need to call render start screen, so it does that. Okay, and then let's go ahead and we'll throw the values we need for this stuff into variables out here that we'll be able to use on this guy as well. Actually, let's throw this guy in here too. Let's call this, instead of just render, we'll call it initialize start screen. That'll be kind of what kicks us off. Initialize start screen. And then we'll put those values in here, because only a start screen needs to know about the button. So we'll call it, let's call it start button rect. And that's just short for rectangle. So its X is going to be, just copy all of this up here. And that's a syntax error, so we can't leave it there, but just for a second, and we'll pull this guy up here. Okay, so, well, actually, I can't do it quite like that. So let's go ahead, put that back down here, and we'll just move this stuff down. Actually, we're going to rearrange our code a couple times, so, all right, that's good enough for now. We'll put this down here. And we have to have our start metric stuff after we've set up the styling for it in order to render it properly. See, we need before start metrics. There we go. Okay, I'm going to put a comment in here so we can keep track. So that's the Pong bit. And we're going to rearrange that again in a bit. So, okay, so our X position is this clump of stuff. So actually, our X, Y, width, and height are all these four values. So X, Y, width, and height. And then we can just pass these into here, width and height. And now we also have start button rect dot start button rect dot height. There we go. All right, and so now we also have them stashed, so when we get in here, we know what that rectangle was, so we can check if we clicked it. So to tell if a single point, which our mouse is just a single point, an X and Y, to tell if that is inside a rectangle. So here's our rectangle. Here's our point. We're going to check is the, and we'll call the, we'll say we have Rx, Ry for rectangle X and Y, and then Px and Py for point X and Y. So we check is the point X greater than or equal to the Rx. So we check this. And then we also check is the point X less than Rx plus, we'll say, our width, and Ry is our height. So we're checking, let's write this out, is Px greater than or equal to Rx, and is Px less than or equal to Rx, or Rx plus Ry, or R width rather, sorry. And then we also go to the same thing for the Y. So is Py greater than or equal to Ry, and is Py less than or equal to Ry plus R height. So if all four of those things are true, that means we're that point is in the rectangle. Otherwise, it's not. So if we'll go ahead, we'll check these in variables. So I'm going to destructure out the offset X and Y. So offset X, offset Y, equals that. So I'm destructuring those out just like I did at the canvas up here. And then we're also going to have X, Y, width, and height, which we're going to destructure out of start button rect. And the reason we're destructuring those out is just so we don't have to type event dot and start button rec over and over and over. So we'll say if offset x, and so remember that's our point, is greater than or equal to x, and offset x is less than or equal to x plus width, and usually if I have to do a bunch of conditional one if statement, I like to put one on each line because it makes it a lot easier to see. Greater than or equal to y, and offset y is less than or equal to y plus height. So if all four of those are true, then we hit. So for now, let's just output, and we'll say hit. And I broke something. What did I break? Let's move this guy down here. Let's do start button rec for this guy too. So that would be the top of the rectangle and then 20 down for the padding. And then we'll leave that as is just because. Okay, what do I do here now? Alright, so set our style stuff. We have our start metrics. We fill style needs to go here. Then we need the other fill style down here. We were drawing our start button blue as well, so we can see it. Oh, start button rec.y. There we go. There we go. Okay. So, and let's go ahead. So we'll test. Do we hit it? We blew up. All right. So y is not defined at blah 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 blah. So we'll hit this to see what line it's on. Okay. So offset y. Oh, there is no y. I accidentally named that w, which doesn't exist. Okay. All right. And now we'll click. All right. So we got a hit. We'll test. All right. So I click elsewhere. No hits. I go inside. Hit. Perfect. Okay. So now what we need to do is we need a way to go from this screen to this screen. So to do that, we're going to implement a rudimentary state machine. And a state machine is basically just a machine, in this case, just a program that just maintains a state. It's actually really straightforward. So the state in this case is going to be what is our current scene. And a scene is just the word we use for what screen we're on, basically. Just like in a movie, you have different scenes. Same thing in programming. So this guy's one scene, this is another scene, and this is another scene. So let's go ahead. We'll create a variable for it. And since this is going to be what the variable that keeps track of our scene, we're going to need to change that. So it needs to be a let. We'll call it current scene. And then what we're going to do, let's rearrange our code a bit so that we can define multiple scenes. So we'll create a concept called scenes, and then we're going to call this one start screen. And then each one of these is going to just be a function. We'll call this one game and game over. And these will be what it should do when we flip onto that scene. And we'll go ahead then, let me put this above current scene so we can reference it. And we'll say let current scene equal scenes.start screen. So we'll start off our scene on the start screen. And then we're going to want to then render our screen, our start screen. But really, so with our start screen, there's not really a whole lot going on. It's just kind of fixed. But our game is actually going to move. And so we're going to need to implement a render loop. And so render loop is basically just we draw the game, we draw everything out, and we handle everything. And then we literally just go back and do it again and again and again, forever and ever. And that's actually how you get your FPS in games. So your FPS is how many times the scene can be rendered in 1 second. So 60 frames per second, you're rendering it 60 times. So your game loop's able to get through 60 times. So that's what we're going to set up now. So in fact, we'll go ahead. So we could set it to a fixed frame rate, or we could let it go as fast as it's capable of going. We'll let it go as fast as it's capable of going. So what we're going to do, we're going to have our loop, and we'll do it down here. So we'll just call it, you can call it whatever you want. I like to call it tick, just because I don't even remember where I got that from anymore. I just have always called like one moment in your game loop a tick. So we'll call tick. So then we'll say constant tick here. And then what we're going to do is we're going to, so after tick is going to basically do everything for our game. And then when we get to the end, we need to basically call tick again. So what we're going to use for that is the request animation frame. So there's a couple ways you can kick off the next tick. You could use set timeout, which used to be my preferred way, or you can use set interval, although you would call set interval for about 5 and it would keep going. That one, it works, but I don't like set interval because if something goes wrong, it's going to keep going wrong over and over again because set interval is going to keep running even if a problem happens. The request animation frame is now the proper way to do this. This is basically saying, as soon as you can, do this thing again. And so we're just going to pass ticking here. So as soon as it's able to get the next animation frame, it's going to call tick again. And now if we just flip over here, and then we need to call tick once to kick off the whole process. We call it once manually. And now here you can see, so we're console logging. Each time this number goes up, it means it's ticking. It's calling our frame again. So now in here, we want to render the screen. So we'll go up here. We'll actually give each of our scenes a couple things. So we'll say there's an initialize function and there's a render function. So let's go ahead. We'll pop all of this stuff into render. And then let's move, and we won't need that anymore. And then we'll move this add event listener. We don't want that to happen every single tick because that would mean our button would have like 1 million clicks, and 1 click would not be good. So we're going to move that up here. And then now we have the issue where our start button was down here, but now we need it up here. So let's go ahead, just for a bit, we're going to do something a little bit ugly. I'm just going to copy, paste, and duplicate this. We're going to rearrange that and make it dry in a bit, which don't repeat yourself. But for just a moment, we're going to repeat ourselves just so we can get the rest of this to work. So now what we're going to do is when we switch to a scene, we're going to initialize it to basically set things up. And then render is going to be called each tick to draw anything that needs to happen. So down in our tick, we're going to do current scene dot render. And so each tick we're going to call render. And we need, or actually, let's make a draw function, actually. I like to split these up. So we have both the rendering, so that's, drawing stuff, but then we also have the game logic where we change stuff before we redraw, because if things never change, then there's no point in redrawing. So we're going to just call draw here, and draw we'll call current scene.render. And then we also, before we render, we need to blank everything out, or else like changes would just stack on top of one another. So we're going to do context.clearRect. We're just going to do 0, 0 width height. So remember, width and height is the width and height of the canvas. So this means we're going to clear out the entire screen. And now if we go back, nothing should look like it really changed, but it's doing stuff. And now we need to call initialize at some point. So we'll call this first initialize just right here after we set up the first scene. So we'll call initialize. And now, oops, cannot set properties of undefined setting font. And if we click this, okay, so context.font. So it said cannot set properties of undefined setting font. So that means the thing to the left of font. So context isn't set. And that's because I just tried to initialize before we created context. So let's put that all the way down at the bottom. And we still need tick. So we'll initialize the current scene, and then we'll manually kick off tick so the game is running. Okay, so we're ticking, and I can still click, so far so good. Okay, and now let's go ahead and we'll make the game, we'll give it an initialize and a render. And for the moment, let's just go ahead, we'll do context.fillRect. Well, let's slap a red rectangle on there just so we know that that we've successfully switched. Okay, so start. Whoops, doesn't switch it. We didn't put that code in. Okay, so here we'll do current scene dot, or current scene equals scenes dot game, and we need to call then current scene dot initialize. And so we don't, and so we remember to do this because we'll need to do that every time. Let's go ahead and just make a function called change scene that can do that logic for us. So let's say new scene, and then we'll do current scene equals new scene, current scene dot initialize. And then instead of calling that manually, and instead of initializing that like that, we'll just not initialize it there. Then we'll just say change scene to scenes dot start screen. So that'll be our first thing that happens. And then we'll do up here change scene scenes dot game. And so that'll change it to our game. So let's go see what happens. Start. Cool. So we switched over to our game now. So now it's, you can kind of see we're starting to get kind of messy already. It's kind of hard to keep track. So let's go ahead and take a moment and let's split files up. So there's a couple different ways you can handle file splits in JavaScript. One of the newer ways, and definitely my preferred way, is to use ES modules, which we're already using by just having type module on here. And ES modules means we can have multiple files, and then we import one. So let's go ahead. We'll go over here. We're going to right-click, do new file. We'll make one file per scene. So we'll do start scene first. Or start, call it start screen. Start screen is a scene though. And then we're going to do, we're going to just create the scene here. And we'll call it start screen. And we'll just copy basically what we did here. Copy that. Put over here. And now we have one extra set of curly brackets. There we go. And that needs to tab over. That needs to tab back. There we go. Okay. And then since now we have a whole file, and the whole file is dedicated to start screen, we don't necessarily need to smash everything into this one thing. So let's go ahead, we'll space things out. So let's go ahead and we'll just say we have image take initialize equals that. And then we'll have const render equals that. Okay. And then the important thing with ES modules now is we want to export something. So we're going to do a default export, and we're going to export an object which has initialize and render as values. Oh, I never fixed it. So now we can come in here and we can do import start screen from. So this is the variable we'll refer to it, and since it was default variable, it can technically be named anything, but I like to keep it named, kind of what we expect. And then from, and this is the file path, so we'll do start screen, and we want to have .js at the end. Okay, and then we'll just put start screen right here in our scene. Technically, we don't even need this the start screen object anymore, but I like to still have one just to kind of group them together, because then it makes it easy to tell what all your scenes are. So now, basic basically just taken that code, but I moved it into its own file. So now we can, oh, it blew up. Why did it blow up? Let's see, make sure it did build. Yep. So why it says 449? Oh, I somehow we ended up with startscreen.js.js. Something. Oh, oops, sorry guys. Okay. Yeah, so I just realized that this build pipeline, just to make it easy, goes ahead and adds .js for you. So we won't add .js. Okay, so context is not defined. So now we have the issue where we're using context, but context is over here. So what we're going to do instead is let's actually, we'll wrap this all up in a function called create start scene or start screen. And in that, we're going to pass context into it. And then I'm going to move all of this into here. And then this function, when it's called, is now going to return this object. Return that. And then we're going to export the create start screen function. And now over here, we'll just say create start screen context, which our context isn't defined just yet. So let's move this stuff up above here. So we have context first, and we want to just rename this create start screen. And I like to, if I'm exporting like a class or object, I like to name it like this. If I'm exporting a function though, I like to actually name the file and the name of the function, just so then it stays nice and clear. Oops, don't change anything in this, like it's built for you. Change this one. Great. So we'll create our start screen, and then we create it, and just so we can see what's going on underneath, I'm going to do console.log create start screen, and I'm going to just the function itself, and we're going to see what it has underneath. I'm going to dump that because it's console log, it doesn't matter. So create start screen.js doesn't exist. Create did I have it? Oh, we're missing an E. I was like, I don't see it. Okay, there we go. All right, and now width is not defined. So, and that's because, just like context, we have our width and height here. So let's go ahead, we'll just pass in, we'll pass in a bunch of things. We'll pass in canvas and context. Well, I guess two things. And then we'll just go ahead, we'll take canvas, grab the width and height again, just because it's easy. We're only using width, so we'll just grab width. And then that means this guy now needs canvas. And up here, it doesn't matter still. But see, so we can see I'm out echoing the variable, or not the variable, I'm echoing the function to create it here. And then you can see it just creates an object just like we had when we were typing it in here directly. It's just all one thing. But now it's just a nice clean file. And now we can go back to, and we can clear out this duplicate stuff that I said we'd clean up. So let's go ahead. We'll pull, let's see. Let's go ahead and we'll just pull all of this up here, just in the top, so we can create start metrics. And then we won't need to calculate that. We will still need to assign these. We'll still need those. And we'll pull start rectangle up here as well. So that way now initialize, and we can now dedupe all of this. So now initialize and render both have access to both of those. We'll see they're nice and small. And then we have one other thing. We want to be able to change the scene, so we need to pass something into here to be able to change the scene. So let's just pass in Um, yeah, to keep it simple, we'll just pass in change scene directly. We can just pass in the whole function for now. Okay, so we'll pass in change scene. That way we have access to change scene and also scenes. So we may go and simplify this later too, but for now, we'll just do this. Alright. So this creates kind of a catch-22 because we need scenes and scenes. So let's go ahead then. We'll create a scene manager. So anytime I have a class or an object that is responsible for managing something, I call it a manager. Programmers are real creative with their naming. So our scene manager is going to keep track of our scenes, basically. So we're going to we'll make this just a class. Actually, no, let's make this a singleton. So a singleton is basically when you have a class or an object, but you only ever have one of them total in the whole program. So to do that, we'll create a class, and this guy's going to have its array of scenes. We'll give it an add scene function, and we'll give each one of them a name and then the scene itself. We could have a remove. We're never going to remove. So if this was a more fully fledged framework or game engine, we would have like remove and a bunch of other things. But I think these are the only two we need for now. And then we'll make this an object. And so when we add a scene, we're just going to do scenes this.scenes name equals scene. And then when we change, we're going to, and we'll have a current scene as well. And we'll do current scene equals this.scenes name. So we'll just grab the scene, and then just like in our other place, we'll do this.current scene.initialize. So we can ditch this guy. And now just like so this gives us class. Now we're going to create just one instance of it, and that's how it's going to be a singleton, because this class isn't exported, so only this file can make one, and as long as this file makes one, or is only the only one who ever makes one, and it only makes one, we'll only ever have one, so we have a kind of a makeshift singleton. So in the export scene manager, notice I did lowercase s because this isn't a class, it's now one specific object. And I'm going to import scene manager. And so the reason we want to make it a singleton is because now if this guy imports scene manager and this one imports scene manager, they're both going to have the same scene manager. So if I add or change in one place, it affects the other place as well, because it's the same object. We can get rid of that. And now we'll do, okay, so we don't need to pass these in anymore. We don't need to pass them in here. Now we would do scene manager dot change scene. Oh, I just realized we don't want to pass scene in here. We just want to pass in name. And so the name we're going to give it will be game. Okay, and now let's go over here now. So instead of this thing, let's delete this. So our scene manager is going to handle it. We will do scene manager.currentScene.render. We will do scene manager.changeScene. We'll call it start screen. And now we're going, and we don't need current scene anymore because that's in scene manager now. We'll do scene manager. We'll do it down here. Scene manager, or actually, we'll do add stuff here. Scene manager.add scene start screen. And we'll create our start screen with the canvas and context. We'll do scene manager.add scene game. And scene manager.add scene game over. Okay, and let's go ahead. We'll scene game and create game over. And we'll go ahead and make these real quick. I'm just gonna make a new file, create game, create game, and it's not going to really do anything yet, except we'll just return a dummy with initialize and render. And export default create game. And then we'll just duplicate this guy. Game over. And game over. And game over. Okay. So, and then we can just add a line here, or in my IDE, I can hit Alt-Enter, and then the first thing I'll have selected is insert, and I can just hit Enter, and it adds it for me. Okay, so let's see if that's still working. We've not really added anything, but yay, it's still working. Okay, cool. And that popped over to our game. Awesome. So now we have a nice little scene manager here that can handle things, and all of our different scenes are nice and broken up so we can keep track of things. Cool. Okay, and that same duplicate. Why is that same duplicate? Shouldn't have a duplicate anymore. I think my ID is just confused at the moment. Let's see, where does it say? Oh, this is excluded. My ID is getting confused between the two and telling me I have a duplicate. Okay, there we go. Okay, so now let's do one final little bit of cleanup. I always like to write what's called self-documenting code whenever possible. And that just means that the variable names and function names and class names all basically describe themselves well enough that I don't need comments to further explain. And this is beneficial for a couple of reasons. One, I just don't have to write comments. That's stuff I have to type. The other, though, and the more important one, is it means if I change my code, I don't have to also remember to change comments. Because one of the most annoying things working is if you like find a block of code and you're not sure what it does because it's not written in a way that's self-documenting, but also the comment is out of date, so the comment doesn't actually match the code anymore, and it's just even more confusing. So that's why I like to have as few comments as possible, because then there's fewer comments to forget to update. So what we're going to do in that vein then is let's split this up so we have one function for render the title and one function for rendering the button. So const render title, and I'm just basically going to copy paste, and we'll just split them up. Then we'll have const render start button. Okay, and then in render we'll just call render title and the start button. Easy peasy. And now, one other thing to do. So the context, one thing that you'll see. So like if I change things, like say I changed stroke style right here. Well, this function, even though it doesn't call stroke style, it's still using this stroke style, and that can get confusing if like you rearrange things and you're like, why the heck is this thing changing? So what a good practice is to wrap all of your style changes in context.save and context.restore. And what those do is basically save creates like a save point of this is of like what the context is when you call save, and then restore restores what it was the last time you saved it. So you can basically make your changes and then switch them back so you never confuse anything. So we're just going to wrap up each thing in that. Or actually, rather than wrapping each of those up, let's go ahead and we'll wrap, in our draw function, we'll wrap any call to render. That way they all reset one another. And we don't have to remember it for each individual one. So we'll do context.save, context.restore. Easy peasy. So then, and one other thing to do, so we do have a bit of undryness right here because we have this stuff duplicated, these styles here. So let's go ahead and we'll pull out, and we'll call this style start button. And we'll pull those calls for the style stuff out just so that we don't have to repeat those twice. So we'll call style start button And start button right there. And then we will go ahead. So this one is already going to be wrapped up because this guy will wrap up in the initialize. We'll wrap this one up and it'll save as well. So after we've measured the metric or context.save, after we've measured the size of it, we can go ahead and put it back how it was because we won't need that anymore. Variable net. Oh yeah, so we can't do that just yet because that function doesn't get made until down there, but I'm trying to use it up here. So let's go ahead and we'll, instead of just putting it right there, because we're going to always call initialize before render, so let's make our start button ref a let, and then we'll initialize its value in initialize. Imagine that. Just like that. Okay. So now, let's just double check. Nothing should have really changed, but nothing should be broken either. Okay, we seem to be good still. Okay, so I think that's pretty good then for our start screen. We have a nice screen here. So now we can go to game, and we're going to kind of do the same thing. So go ahead and we'll make a separate initialize function. We'll make a separate render function. And then these will just return those because they have the same name. And then we'll go ahead and we'll import Scene Manager. Okay, so let's talk about our game. So let's break it down. So we have the paddle to draw, the ball to draw, the score to draw. We have to keep track of the score, and we have to handle moving and stuff. So one thing at a time. Let's start. We'll draw the left paddle. So in our game, the left paddle is just going to be a rectangle. So now the question is where to draw it. So for each of our paddles, their X position doesn't change from where they start. So let's just say maybe 20 pixels from the edge. So that means this one's X will just be 20. And because they don't change, let's just make a constant up here. Let's call it, I don't know, edge padding maybe. We'll say 20, so 20 pixels. And then we don't have anything we're going to initialize right now. Let's just draw the paddle. And let's go ahead. So we have two paddles we're going to draw, but we're going to draw them identically. The only difference is where they're going to be slightly different. So let's make a function draw paddle that will take an X and Y. So we can, and then we'll say here, draw paddle. So the X for the player one will be edge padding. So it'll be 20 away from the edge. And then for now, we'll just set this to like 100. We're going to need a variable for that in a second, just so we can draw it, because we want to do one thing at a time. So for this now, we're going to do, so create game is going to get canvas and context passed in, because that's what we're passing in. We're going to do context. Let's just do, let's do blue, still style. We'll do that blue color I like. Okay, and then we're going to, okay, now we're going to do still rec. We're going to do X and Y, and then we need a width and height. So we'll just put, we'll make those constants as well. And the reason you want to put values that you may need to, like they don't change in the program itself, like when it's running, but you may need to fiddle with, like the paddle size. It's good to put those all in constants in like one place, or like, you know, a couple places, wherever it makes sense to logically group them. Because then they're all nice up here in one little spot, and you can fiddle with them. And if we refer to one multiple times, we don't have to go find, you know, the 50 times we typed 40 or something. So we'll put them up here. I'm just going to pick 10 and 40 for now. They may work, they may not. We'll play with them as needed. Especially in game design, a lot of stuff is kind of, you pick a number and then you fiddle with them until you get it right. Kind of all of programming is like that, but especially game design. Okay, so there we go. It drew rectangles. Yay. And let's go ahead, just as a shortcut. So every time I refresh, it's going to go back to the start screen. Let's just temporarily change what screen we start on. That way you don't have to do that every single time. We'll begin. Oh, and I just realized I forgot one thing I wanted to do. So anytime you have to type a string repeatedly, so like we name it up here and then we type it here, it's best if you can throw that in a variable somewhere, because you don't want to make a typo, because like my IDE doesn't know, like, is it start screens or is it start screen or what? It can't help me with that. If I throw it into a constant though, it can. So we'll just make it a constant. We'll call it, we'll just say scenes, and we'll do all caps because it's like a constant. And then we'll just do start screen. And I'm just gonna, the name doesn't really matter. I could put Cookie Monster inside the actual string. As long as it's consistent, it doesn't matter. But we'll just do the same thing repeatedly. Over. And then now I can do, actually, we're going to capitalize that one. I always go back and forth on how I can capitalize things, but when it comes to constants, but usually this is how I do it. Scenes.game and scenes.game over. And now the benefit of this is, so before when I changed the string and if I made a typo and they didn't match, my ID couldn't help me and it'd be hard to find. Now though, if I make a typo, my ID is like, I don't know what you're talking about. Are you sure that's right? It's the unresolved variable. So having a variable helps avoid those little weird, annoying, hard to find typos. Okay, and then this line is temporary, so I'm going to comment that one out, and we'll just start on our game screen every time now. So see now when I refresh the page, yay. Okay, so now, so we render that paddle. Let's go ahead then and make it move, because why not? Okay, so to handle movement, we're going to add an event listener to, one thing at a time. So let's add an event listener to the canvas, or not to the canvas actually. So handling keyboard events in JavaScript is a little funny. You have to have something that can have focus to be able to attach a keyboard event. So usually you can just attach it to the document itself, and that's usually good enough. And we'll do that. We'll do console.log key down. We'll just check and see if it works. So yay! All right, so cool. Every time I press the key, it works. All right, so cool. All right, so now we have, so to track keyboard events in a game. So there's like regular JavaScript for a web page, you may not need to keep track of everything, but for a game, we want to keep track of all the keys that are down at the same time, because we may have a user pressing multiple keys, and in fact we will, because we're going to make a two-player version. So we'll do W and S for player 1 to move up and down, and we'll do the arrow keys for player 2 to move up and down. So that means we may have 2 or even really 4 if they want to hit all 4. So we're going to keep track of all the keys that are down. So what we're going to do, let's create a function called keys down. All right, not a function, a variable. It's going to be an array. And anytime we press down a key, we're going to add it into keys down. And so to know what key we pressed, there's actually a couple ways you can do that in JavaScript. So I output the key or the event. So we have either key, just key, which is a string, and it's like key down, or if I do letters, you can see it's the letter itself, or if I do like the insert key, you can see, so there's different things. And then we also have the code, and sometimes the code and key are the same, like in here. Sometimes they're different. So you can see here the key was just the letter itself, and then the code was different. And you also have the key code, which is a numerical representation. It doesn't super duper matter which one you choose. Just make sure you are checking for the right value for each. So we'll use code, and so the values we're going to care about will end up being T, W, T, S, and then we can hit up and down arrow, and arrow up and arrow down. So let's go ahead, let's check those in constant. And you know what, we'll call him player 1 up. We don't actually care what key it is. We just care that it's the key assigned to player 1, and player 1 down, key S, and player 2 up. And that way, too, if later on you decide, arrow keys are kind of bad and I want to switch to numpad or something, you could do that without having to rename a bunch of things. So we have those keys, which we'll refer to later. But for here, we don't care which keys press. We're just going to stick them all in keys down. .push event.code. Except we don't want to push the same key because, I'll show you. So keys down is going to fire over and over and over as long as the key is still down. So you can see here, I'm just holding down the arrow key, and it's adding it repeatedly. Oops, and you can see here, this is our keys down array. I've added it about 1 million times. That's just pointless. So we'll just check if not keys down.include event.code, then we'll add it. So if we haven't already added it, we will. And now we can log keys down. And we'll see, I'm just holding the down arrow again. And we can see that now it just gives us one total, even though it's being called a bunch. So that's what we'll do. And then on the flip side, when we let go, we want to get it out of that array. So we're going to do document.addEventListener key up. And it's almost identical, except instead of pushing into it, we need to splice it out. So we're going to do const index equals keys down dot index of event.code. So this will tell us if the index of in this array of this code key, if it's in there. If it's not in there, it's going to be -1. So if index equal -1, well, it's return. And just as a friendly reminder, in JavaScript, 99.99999% of the time, you're going to use 3 equal signs. Don't use 2. It'll create weird, annoying bugs that will take forever to find, and just don't do that to yourself. Just always use 3. Okay, so if it equals 1, we're not going to do anything because somehow they let go of a key that wasn't down already, which shouldn't, sounds like it shouldn't happen, but like you could like say like if I hold down arrow right now and Alt Tab into Chrome, then let go, the key actually will fire an up event without the down event. So we'll just have that check already. And then if we did find an index, we're just going to do keys down.splice. And so splice lets us either put stuff or delete stuff from an array. So you can see there, start number, so that's the index. Then delete count, we're going to delete 1. And then we're not going to add anything. So that will pull the key out of our array. So we can, and we'll just go ahead, we'll say in render, we'll do console.log keys down, so just every tick will output, so we can kind of keep an eye on it as we go. All right, so nothing, nothing, nothing. I'm going to press down. I'm holding down. I'm holding W. I let go of down. I let go of W. Keyboard smash. Let go of things. Looks pretty good. All right, so let's get rid of that console log. Okay, so now we're keeping track of if our key is going up and down. Okay, and now I want to refactor this guy just a little bit again. I want to add into each of these their own tick because we, just like the main loop needs like a function to do stuff and then a function to show stuff, our scene is going to do the same. So we're going to add a tick to each of these as well. And if it doesn't do anything, that's fine. So like this guy doesn't need anything in tick, so I'm just going to throw in a dummy tick. Or perhaps better, let's go back to here, and we will do question dot. And so what this question dot says is if render exists, call it. And if it doesn't, it won't. So we can call it if it exists, but we don't have to give it if we don't need it. Just That way we don't have extra stuff floating around that we're not actually using, which is always nice. Okay, so now we'll call the tick here, and then we will, we're going to call render2. And so in tick now, we will, if the key is down on a tick, we're going to move the player, if it's one of the player's keys. So first we need to have a variable to keep track of where the player currently is. So let's just go up top here. We'll make a let because we're going to change it. Player1x, or player1y, sorry, because we're up and down. And let's start this off, and actually we'll put it in here. And we'll start it off with the paddle in the middle. So if we want it in the middle, we'll do canvas.height divided by 2. So that'll be halfway down the canvas, and then we need to shove it back half the paddle height. Paddle height divided by 2. So that's where the player will start off. And if we go, we can refresh. And if I didn't screw and we need to actually use that variable, player1y. There we go. So it's in the middle now. So now each tick, we're going to move the player. So just to kind of get us started, we'll do if keys down dot include keys dot player1 up. Then we'll do player1 y minus equal 5 or minus equal 1. So remember, up means negative numbers, so we'll subtract 1. Else if keys down dot include keys dot player1 down, player1y plus equal 1. So down would be increasing. Okay, so here we go. So didn't seem quite. So let's do console log keys down. Let's make sure we'll check two things at once. We'll check that our tick's being called, and we'll also check that keys down has the key prefix. So refresh the page. Okay, so tick's not being called because we're not getting anything else with it. So let's go double check that then. So scene, current scene dot tick. Should be there. Scene manager dot current scene. We'll output the current scene. Just double check that it actually does have it. This tick isn't being called either now. What did I do? Interesting. Alright, so our tick should be called here. Oh, you know what? Let's double check that our build pipeline hasn't run up on us. Oh, shoot. Okay. So this syntax is a special syntax, and apparently I don't have it enabled in the pipeline. So this little bit of fancy stuff we're going to add to our Babel pipeline. We need the optional chaining plugin. Okay, and then it's this guy. I'm going to do. So this is getting a little advanced, so I wouldn't worry too much about this. But what I'm doing is I'm installing a plugin for Babel. And what Babel does is it basically transpiles new, shiny, latest, up-to-date, most modern, awesome JavaScript into slightly older versions that older browsers are able to read because they don't always have all that shiny newness. So that way we can use all the shiny newness while not worrying if the browser can actually handle it, because Babel's going to take care of that for us. So the optional chaining, that question mark bit that I did, is one of those new shinies. So I'm going to go pop that into here in the Babel file, which is our configuration. And so there's a bunch of different plugins and presets you can use. So we're adding the one for optional chaining, so Babel's able to handle that. All right, so now if I rerun, hopefully it can work. And the reason, just in case things weren't clear, the reason things weren't changing earlier was because we weren't building, so our code wasn't getting refreshed, because that's how this build pipeline is. Right? If server, we should be on this one, and we have to log in. That will literally just do. Alright, let's see, npm run. Yeah, client build. Easier to tell what's running out. Yeah, so it's false. So that's what we expected. So it should output this set and plugins, and we have that plugin there. That is curious, but not doing what we expected. And let's double check that I did install it. I did. Alright, so let's do this. I'm going to screw that up just to see if it's actually getting in here, because it should be out. Okay, so it is getting in there. Well, that's even more curious then, because I just think that optional training isn't there. Curious and curious here. Plugin proposal, optional training. Plugin proposal, okay. So I have the right one there. Let's see if it needs some extra configuration. Nope, we just slap it in there, it looks like. I wonder if double check that this one can handle the function version of it too, because that actually might be a different one. So I think I saw an example of it. Yep. Huh. Missing plugin optional chain. Curious. Alright, well, I don't want to spin our wheels too much on this, so what we'll do for now is we'll just go swap out the syntax to an older one. So instead of doing that, we're going to do and manager.current.take. So this is kind of the old-fashioned version of the same thing we had. So first, this part checks to make sure that tick exists, and then we call tick. So functionally, it's the same. It's just obviously, kind of longer and more duplicating and annoying, but good enough for now because I don't want to spin our wheels on that right now. So let's run dev, get our build pipeline back up. Okay, there we go. And now, okay, so built. So let's pop back over now. We should be getting console logs again. Not. Still. Oh, there we go. Refresh one more time. I'll go a little too quick. Okay, so now if I hold down or hold up, not really moving, is it? Okay, so we are getting the value. Oh, this is layer 1. I'm hitting layer 2's keys. Okay, so cool. It works. Yay. Okay, so here's an important thing when we're dealing with doing any action that we do like over time in a game. So if you remember earlier, I said there's a couple different ways we could do this. I could have like set a frame rate, and we could have been like, we're always running 60 frames per second. And so like if say I want the paddle to be able to move like a maximum of like 10 pixels per second, I could have used that 60 to do math to figure out and make it move an appropriate number of pixels. But instead we're like run as fast as you can, which is usually the better option. In fact, it's almost always the better option. But what that means though is if I want to do 10 pixels per second, I actually need to keep track of how long it's been since the last tick to move. So let's go add that. So what we're going to do, that's going to be the main tick's job, and it's going to pass that into each of these. So to do that, all we do, we'll do let last time with date.now. So this will give us a timestamp of when the last time we ran. So we're going to initialize it with now, and then the first tick will basically be 0, so it won't really do anything until the second tick. Then inside the tick, we're going to do date.now again, and it's going to be now. And then our delta, which is the difference between how long it's been, it's the difference between the current time and the last time, which tells us how long it's been since the last time we were able to run. And we just do now last time. And now finally, we'll update last time to be now. So this delta will tell us how many milliseconds it's been. And that's also, we can use that to find out our FPS. Let's turn down our console logs now. We have a few too many. Okay. So we can see here, so this is a millisecond. So remember, there's 1,000 milliseconds per second. So we could figure out our FPS, and this is actually pretty consistent, 16, 17. So like if we did 1,000 minus 16, so we're currently running at 62.5 frames per second. Or, well, really it's 0.5. So we're running at 60 frames per second, which makes sense because that's usually what browsers run at. So we'll pass in that delta now into tick. So now all the other tick functions have that now that amount as well. So now let's go up here. Let's make another console or an airport pitch. So we know what these are. So we'll do a let's call it max speed, or we'll be fancy and all physically appropriate and call it max velocity. We're fancy. So let's say maybe 40 pixels per second. And we could do pixels. You could also do like percentage of the field size or however you want to do it. Well, let's say 40. And then what we'll do, we do want our paddle to like, not instantly move, because part of the challenge with Pong is as the ball is bouncing back and forth, you want to be able to make like that slap shot down to where they can't get to it. And so you want your paddle to kind of like changing speed. You want it to take some time, so it'll have to come to a stop and then accelerate back the other direction. So we'll also do a paddle acceleration, being all physically appropriate. And we'll say this is 10 pixels per second per second. So that means, and that's going to be too low. Let's go actually 80 pixels a second, which would mean it would take half a second to turn around, basically. So pixels per second and pixels per second, or second squared. That's how you measure acceleration. And then what we'll do is let's have inside here, we'll do player 1 speed, and that'll be equal to 0. So now what we'll do is each tick, we're going to adjust the player's speed by applying some acceleration to it. So player 1 speed, and this is down, so that'll be minus equals paddle acceleration. And now here's where the delta comes in. So if we just did this, it would dump negative 80 on it 60 times a second. So that would be that would actually be what, 80 times 60? That would actually be an acceleration of 4,800 pixels a second. So that's not what we want. So we're going to multiply this by 1,000 divided by delta. And so that will adjust paddle acceleration so that so that we're going to get the speed we actually want. So in this case, 80 pixels per second change, we're going to get that right value. And this works, and the reason this is the best way to do it with the whole time delta is whether we're running at 30 frames per second, 60, or 800 frames per second, it's always going to let the paddle move exactly the same. Whereas if you base it on every tick based on how many frames you have, that speed wouldn't be the same unless your frame rate's always the same. So this is kind of the proper way to handle any kind of really changes over time. So there we go. So now, and so now we should be able to accelerate. If we're not, so let's see here. Player one speed. So we're changing the speed. Oh, and I keep using the right player as control, so I wasn't even hitting the right button. We want to change the speed, and then after that, we're going to add that speed to the player one. And same as just like acceleration, we're going to do that by delta because it's pixels per second. So we want to apply it based on how much of a second has changed. Okay. So now, okay, that's a bit bigger a number. Hang on. Oh, yeah. Delta divided by second. I did 1,000 divided by delta. That tells us our FPS, which is 60. So I just multiplied paddle acceleration by 60. That's the opposite of what we want. We want delta divided by 1,000 because we want the fraction of a second is then. So I just tweak that. Okay. There we go. And you can see how it just keeps going. Come back. There it is. And, so you can see it keeps going. So we actually want to have a deceleration on there. So if I'm not hitting a button, so like I'm not hitting a button right now and it's still moving, we have nothing to slow it down here. So let's add a paddle deceleration, which deceleration is just acceleration in the opposite, slowing down. We'll say that is, we'll go 120. So we can decelerate a little faster than we can accelerate. And we can always fiddle with these. That's why they're up there. And that is not how you spell deceleration. Deceleration. There we go. Okay. So if we're not hitting up and we're not hitting down, let's go ahead for player one. We'll do speed. And now, so here's the tricky thing with deceleration. So we may be moving up. We may be moving down. We want deceleration to be the opposite of whatever that is. So we can't just like say plus or minus because it may sometimes be plus, it may sometimes be minus. So what we'll do here, we'll do plus, but we're going to then need to figure out, is this a negative or a positive number? There's a couple ways to do it. We'll keep it simple. We'll do a ternary here. So if player one's speed is less than 0, that means it's negative, which means we're going to want deceleration to be positive. So it's the opposite. Or we'll do -1. And then we'll do, so that will give us our sign. So it will be negative when it's supposed to or positive when it's supposed to. And we'll multiply that by paddle deceleration times delta divided by 1,000. And okay, so that will almost work, except it should do it. Oh no. Okay. You don't really need to. Our deceleration is slow enough that you can't tell. Technically, it could wobble back and forth for a bit to come to a dead stop, but it looks like it's actually okay here. But we'll go ahead and clamp it anyways. So clamping is just basically when you force a number to be within a range of 2 values. So let's make a helper function. So we'll make a new file. We're going to call it clamp. And cut clamp equals, so the first parameter will be the value, the second will be the min, and the third will be the max. So to clamp a value, we're going to do math.min, and then we're going to do, and this is where things get, it's a little funny here. So we do the min of the max and the max of the min, and it looks totally backwards, but if we draw it out, it kind of makes sense. tablet. So we have like, say there's a number line here. And we have 0, 1, 2, 3, negative 1, negative 2, negative 3. And say we want to clamp a value between 2 and negative 2. So we say, so negative 2 is min, positive 2 is max. And so we say, and let's say our value was 0 first. So we would do math.min of max or 0. So if, say, if our value was 3, so between max and value, the smallest of those numbers is min. So that forces us into here. And then inside that, we have math.max, and then it's either min or the value. So if our value was negative 3, the min between negative 3 and negative 2 would be negative 2. Or sorry, the max of between those would be. So that forces us to be always within our range. So that's why they're kind of, they seem flipped, but they're not really. And clamping is really useful, and we're going to use this for a bunch of things. And so then we're going to export default. And there we go, little clamping function. And so here we're going to do, so we can't use plus equals with our clamp, so we're just going to do equal, and we'll call clamp. And then we'll do, oh, actually, we're not being very physicsy. Call this max, player one max velocity. And it just used the refactor feature of MyAD, so it swapped all of those at once. Okay, so the value itself is going to be player one velocity plus, and we'll go ahead just to make it more readable. We'll call it deceleration change. Okay, so the value would be then player one velocity deceleration change. Oh, and actually we don't need, well, no, yeah, we won't clamp here. Yeah. We can do a clamp in just one spot. If we just wanted it there, we could just do min, but we'll do it so we'll do the clamp down here, and we'll clamp it in both directions. So player one velocity equals clamp player one velocity. So the minimum we can go is actually it's a little tricky. Well, yeah, we won't worry about that for a second, because the trickiness is you can technically go between these two. So we'll clamp this so that way we can't go above max velocity, because otherwise we could just keep going faster and faster forever. Okay, so we do the velocity, then we apply that velocity to our player's current position. So now we have a nice physics-based movement. It's kind of slow. So let's go ahead, we'll fiddle with a couple values real quick. Let's make our paddle a little taller. Let's crank up the max velocity, maybe quite a bit. And then we'll crank up the acceleration and deceleration as well. So let's try those numbers. All right, I don't know, deceleration might be good. You could, if you wanted, you could like have deceleration really slow, and then you'd kind of have like a drifting value. It's kind of hard to see, but really, really low. Can we use some deceleration, right? Because that shouldn't be that fast. Deceleration, blah, 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 times blah, 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 times blah, blah, blah. Oh, there it is. I had taken that off and forgot to put it back on. There we go. All right, so now, see, so, narrate. You can't like this. All right, so I'm hitting it, let go. See how it keeps skidding because our deceleration's so low? And that's an insanely low above, but like if I do like 100, a little more reasonable, but still pretty soft. Holding, let go. See how it kind of skids to a stop? So you could potentially make your game like that if you wanted, but we'll do a pretty responsive deceleration. So it still moves for a second, so let go. See, it still goes for a bit, but it's not like so bad that you have to deal with it. And you can see too here, I'm flipping, and it kind of takes a while to curve back, so you can't like pivot on a dime. You have to actually slow down to a stop and then go the other direction. So that's kind of a nice feel for it, I think. And of course, too, after the stream, if you want to play with the numbers, you can always download this and play with them and adjust them yourself. And now finally, let's clamp. So right now we're still able to, oh, it did it. It scrolled off. So let's clamp to player Y to be always on screen, so we can't go off screen. So player 1Y is the value. And then, so the minimum we could do is 0. And remember, let's see. We are drawing the paddle based on the middle, aren't we? We are. So the minimum we want to go then is actually half of player's height, because, or paddle height rather, because we don't want half the paddle off the screen. And then the maximum we can go is the height of the canvas, which we didn't destructure. Excuse me, let's go destructure. Actually, we never destructured it. Destructure that now. Canvas. We will need width later, so I'll leave that. And then height. So it'll be height. So height would be the bottom of the very bottom of the canvas, and then minus half of player height. So this will let it go right up to the edge without going off the edge. So, oh, there should not be a 0 in there. There we go. All right, so wait, hang on. Maybe we're not drawing it based on. Oh no, we're not. Never mind. So this is just 0, and this is just height minus the whole paddle. And then this we also want to, oh no, that's right. Yeah. Okay. Now right up to the edge, and right up to the edge. Perfect. All right. So now, and let's actually do one last thing. So right now, if you go and you hit, and then you have to turn around, see how there is a lag. So like I changed our way, but there's lag because we still have to decelerate. But really, we just ran into a brick wall, so the brick wall stopped us. So we should drop our velocity to 0 if we clamp that. So we'll check if player 1 y equals 0, or player 1 y equal height minus paddle height. So our min and max, we're going to set player 1 velocity to 0. And so now I should be able to smack into the wall and kind of use that as a quick turn. There we go. See, there wasn't that delay. Okay, so that's a great point to take just a bit of a break. I have to go take care of something. Be back in maybe 15 minutes, and we can get going again. So I'll see you in just a bit. Hey guys, we're back. Alright, so let's jump back into it. So we had just got player one to work. So let's go ahead, let's refactor a bit so we can reuse this code for player two. For player two, all of this is basically the same. So let's pull it out. So basically we calculate the new position and velocity and return those as values. So make a new function. We'll call it calculate movement maybe, and then we'll say we'll pass in the velocity. We'll pass in the y value, and we'll pass in the direction they're moving. And the direction will be either -1 or +1. So let's go ahead, we'll copy all this over here, or we'll move it actually. And then we're going to rename all of these velocity, or whoops, not move this bit yet. Okay, so we're going to change this to velocity, this to velocity. And so I'm changing it from the player-specific ones to the more generic ones that we're passing in here. So this is velocity. We're going to let's pass in delta too, but let's call it delta seconds. Actually, you know what? Let's just change. So we divided delta by 1,000 4 times. I don't like doing anything 2 times, let alone 4 times. So let's actually, when we pass in delta, we'll pass it in seconds. We'll go ahead and convert it from milliseconds to seconds. Then we'll flip back over here. Okay, so now we'll give it delta, and we'll just make this just delta. We don't need to divide by 1,000 anymore because all of them are. Okay, and then we'll clamp y, and now we don't really need this done twice like this, so we can just do y plus velocity times delta, just get 1y. And then if y equals 0, or y equals height minus paddle height, so those are the same for both players, so those are okay. We'll say y equals 0, then we'll return in an object velocity and y, because we'll need to update those. Okay, and then direction. So here we have, so basically we have 3 options for direction. We have negative, which means we're moving up. We have positive, which means we're moving down. Or we have 0, which means we're not moving and we need to decelerate. So we're going to come in here and we'll basically say if direction equals 0, we would do the decelerating code. So velocity equals, or plus equals. So, and then we're checking which way the velocity is, times deceleration, and then we're not dividing delta anymore. Otherwise, direction is either going to be -1 or +1. So we'll do this, and we'll always plus, but we'll multiply by direction. So if direction is negative, then we're really subtracting velocity. And again, we're not changing delta anymore, or we're not dividing by delta. Okay, so now we calculate our movement. So now what we'll do is we'll say player 1 direction, and then we'll say keys down dot include keys dot player 1 up. Then we'll do 1, or sorry, -1, because up is negative, or keys down dot include keys dot player 1 down 1 or 0. And normally you want to avoid nested ternaries, which is what this is. But I think this is one of those cases where I'm personally okay with the ternary because it's pretty straightforward. It's basically you're figuring out 3 options based on 2 values. But if I do a nested ternary, I like to split it up like this so it's at least easy to read. So basically this same bit as this. So if we're moving up, we're setting that direction. Otherwise, if we're moving down, we're 1. And if we're not moving up or down, we're standing still, so we're 0. And then we'll replace this. We'll do y velocity equals calculate movement. And then we'll pass in all the things we need. So delta player 1 velocity. So here's where we pass in the player specific values. And then player 1 direction. And then we'll take these new ones and update the player specific values again. Velocity. Okay. And now let's go ahead. So this is still in the generic tick function. Let's go ahead and move this to move player 1. We'll make a move player 1 function. And then we'll make a move player 2 function, which is very similar, just slightly different. Move player 2. And did we make the player 2 variables already? We did not. Let's make the player 2 variables. Player 2. Actually, you know what? Let's go ahead and use objects for these instead. So we'll just make one player 1, and we can keep track of everything in player 1 in one object, and then we can keep track of everything in player 2. And then the nice thing about that is we can streamline our code even more and be even more dry. Dry is good. And in case you've never heard dry, dry is an acronym for don't repeat yourself. And it's one of the more important programming philosophies that you want to try to follow because it makes your life much easier down the line. Okay, so we have player 1, so let's go ahead, we'll update this then. So now that we're in a player 1 specific function, we don't need, or actually, let's stop for a second, and we'll be more dry so we don't have to duplicate this twice. So we'll just say move player, and we'll pass in the player object. And we'll do move player, player 1, move player, player 2, and then move player direction. And then, so let's attach what the up key and down key are for each player into here. So up key, we'll say key up. I like to, if I have like two things that are related to one another, I try to have the common word at the start just so then they look related. So key up in this case is keys.player 1 up, key down is keys.player 1 down, and then player 2, same thing, just player 2. And now really this is slightly redundant because we're never going to use this directly, but we'll keep it anyways just to be nice. So now here we have move player 1, 2, and then here we can do player.key down. Here we can, or key up. Here we can do key down. Okay, and now here we pass in, delta. Okay, so we calculate the direction. All right, and this is player.velocity, player.y, and direction. And then we can just do, so we can do player.y to y, player.velocity equals velocity. But since they're the same thing, what we can actually do is we can do new values, and we can say object.assign to the player the new values. And so any keys in here are going to get copied onto player 1, so it'll copy our velocity on a y there, just to do it in one line. Oh, and this can be a const because we're no longer changing it. All right, so there we go. So now we have our code for moving two players, and we need to update this to be player 1y. And we can also go ahead and draw our player 2. And so player 2, let's go ahead. We'll just, even though it'll never change in the game, we'll just swap in an X in here as well, just so it's easy. So the player 2's X now is going to be, it'll be canvas width minus edge padding. So width minus edge padding. Okay. Actually, let's rename edge padding because it's really just X padding. So we'll call it X padding. Or even better, let's call it padding X in case we add a padding Y. Okay. Oops. Why didn't we get player 2 to draw? Draw paddle, player 2. Oh, right now they're on top of one another, so that's why we'll do player 1 and player 2X. There we go. Oh, we also, for here, see how it's a little closer, we need to also subtract the width of the player, the paddle itself from there. So, where'd it go? Minus paddle width. And there we go. Okay, so W, oops, C is not working. Okay, let's check on that. Oh, okay, so down doesn't work at the moment. So do something probably in that direction, ternary. So let's go take a peek. Okay, so direction, so keys down, players keys up. Otherwise, keys down includes, oh, not keys, player got key down. Okay, so up, 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 down, 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 up, 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 down, down, down. All right, yay. So we figured out player 1, and then player 2 was just a matter of refactoring our code and passing in a different variable. So yay. So now we have player 1 and player 2. Awesome. All right. So now let's go ahead and we'll figure out how to, we'll do the ball now. So let's, just like we have player 1, player 2, we'll make a ball object. And we'll have an X and a Y. So for the ball, it's going to start in the middle of the canvas. So we'll do canvas.width minus, and let's create a constant for the player, or for the ball. So the ball is round, so we don't need a width and a height because it's both are the same. So we'll call it ball diameter. And we'll go with 20. We'll start with there. We can always tweak it. And you could even, like, if you wanted to enhance this, you could add, like, power-ups where if the ball hits, then, like, the ball gets larger or something. So you can kind of go crazy with stuff. That's one thing I like about game design, especially for little games like this where you're just kind of having fun. You can, you know, really kind of go crazy with it and do silly things. Okay, so and I slapped on a velocity, and it of course doesn't have keys because it moves on its own. And then we'll go ahead, let's do a direction. And we will, or actually, let's not do direction there. We'll put direction in initialize. Oh, actually, you know what? We should put, well, worry about that. We'll have to move X and Y and all these. Actually, no, let's worry about it now. We're going to move all this into initialize because that way if we restart the game, we need all the paddles and everything to restart. So we're going to put all this in initialize, but we need to declare the variables outside of initialize. So let player 1, let player 2, let ball. That way it gets reset if we, because remember, we're going to, once we get to the game over, if we hit play again, we come back here. So we need the ball to recenter and all those. So this will take care of that for us. And then we'll go ahead and each time we initialize it. So the ball is going to have a velocity, or it's going to have how fast it's moving and then also what direction it's moving. And there's two ways you can kind of record that. The first one is to have a single velocity, which we'd call a scalar velocity, and then a direction, which would be an angle. We could alternatively have a velocity in the X direction and a velocity in the Y direction. You combine them. Which one you use, kind of, it's, you know, a matter of what you're doing with it. In this case, we always want the ball to be kind of moving, you know, the same total speed. So we'll go ahead and we'll do a velocity and an angle. That way we don't have to worry if we're moving 45 or, well, we can't move 90. That would be a stuck game. So we'll do an angle. And we're going to use radians because we're going to have to do a little bit of trig, and all of our trig functions take radians. So we'll do 0 in radians. So actually 0 doesn't work. We want to start at a 45-degree angle. And we'll kind of randomize it. So let's see. So if we have, all right, so we have our ball. We want it to either move that way, that way, that way, or that way. So these are all 45 degrees, or in radians, that it's what, half a pi? Yeah, half a pi. So 1 pi is up. So to start with, it'd either be half pi, or each of these is 90, so we add pi. So this would be 3/4 pi, or 5/4 pi, or 5 halves pi rather, or 7 halves pi. So if we want to do a formula of this, so we'll do a random number. Let's see, how can we do this? So if we create, say, a random number that's 0, 1, 2, or 3, we could then say, so we want this to be 0, this to be 1, this to be 2, this to be 3. So we can really say 2 times our number plus 1 pi is divided by 2. So 2n plus 1 pi divided by 2. And now and where n's a random number between 0 and 3 inclusive. So to create a random number at all, we do math.random first. This gives us a decimal number between 0 and 1. We want to turn that into a integer, a non-decimal whole number. We would floor it. But of course, if we floor a number between 0 and 1, we'd always get 0. Floor basically just rounds down. There's also ceil, which rounds up. So we're going to round down. We're going to multiply it by 4. So because we're between 0 and 4, we might get like 0.1 times 4. That would be 0.4, which rounded down would still be 1. Or we may get like 0.5 times 4, which is 2. So that would be rounded to 2. So that gives us an even number that's either 0, 1, 2, or 3. It's 0 to the number right below whatever the number we multiply by. Okay, so that gives us a random number between 0 and 3 inclusive. And then we can do our little formula we just came up with. So we'll multiply the random number by 2, add 1 and pi, and divide it by 2. So there's that, times 2 plus 1. Times math.pi, because our pi constant, divide by 2. So this will now, each time we start the game, the ball should randomly move in one of 4 directions. And actually, we'll initialize its velocity to not be 0, because we want it to move. And so to move. With 0, it's staying still. So let's rename this to paddle max velocity. We'll do a ball max velocity. Let's see. So paddles have a max of 2. Let's say the ball has a max of 4 pixels a second. And again, we can always play with those and tweak them. And so, but we don't want to start out at the max. So let's say we start out at, half speed. Why not? Okay. So and now let's draw the ball. So we'll make a new draw ball function. And we don't need to pass in x and y because there's only one ball. So we'll just go with that. And actually, let's move these guys up with tick. And that way all the draw functions can be clumped together too. All the draw and render functions. Okay. Draw ball equals. Okay. So here's where we're going to do a little bit of trig. So we have our angle we're moving and we have our velocity. So the ball still is only set in x and y. So to figure out an x and y based on a velocity, we use a little bit of trig. So I'm getting ahead of myself. So first let's draw the ball. So we'll do context.fill style. We'll make the ball white and we'll give it a stroke. stroke style, and we'll just go 3, which is an almost black gray, but not quite. And we'll do a line width of 1, so just a small stroke. And then we'll do content. So to draw a circle, unfortunately, there's no fill circle or fill ellipses or anything. We have to do an arc. So to do that, we begin a path, and this is kind of if you might have played with in like early elementary school. Sometimes you'll like they have a program that has like a turtle, and you like issue commands, and the turtle moves, and you draw shapes. That's a lot like what a path is here. So so we begin a path which doesn't really do anything other than starts a path. Then we're going to use move to, and here we're going to set it to the ball of x and y. And in this case, we will actually yeah, let's actually, for this, we'll have the x and y of our ball actually represent the center of the ball, whereas the paddle represents the paddle, but life will be a little easier if we do the center. Well, kind of. And I guess it's half a dozen of one, 6 of the other. Forgot how that saying went. Let's see. Eeny, meeny, miny, mo. No, we'll keep it so it's top corner, just like the others. Okay, so we'll move the ball to x, y, and so how we do this basically is this is just our screen. We put down a point, so this is move, and then we're going to use arc, which basically draws an arc, a curved line, to the next point we do. And so to get a circle, we have to arc 4 times, basically. So we'll do move to, so we'll start, so this is x and y, and we position, so that's the top left corner of the ball, which actually isn't quite where we want to be, because, so if we have, so here's our ball, and then here's kind of the invisible box around it. So x and y is actually here. The ball x and ball y are actually this. And so see, that point's not actually on the line, so we don't really want to do that. And we're really touching. So we're going to start down here. So we're going to do still bx in this direction. We're going to do by plus half of ball height as our starting point. Down. All right, so plus ball and ball diameter divided by 2. So that puts a point on. That won't actually show anything yet. Now we're going to do line, or not line 2. Line 2 would be if we wanted a straight line. We don't want a straight line. We want an arc. And I will almost certainly mess this up the first time, but let's see what happens. Okay, so the x and y are where we start. So that's the same as what we just had above. Yeah, for whatever reason, arc doesn't feel like an intuitive function. I always goof it up. Our diameter is, or our radius is half diameter, good old geometry. Our start angle in this case is, this is the part I mess up because I think 0 is actually at the top in JavaScript, if I remember right. So 90 degrees from that is pi, except that's anti-clockwise. So we'll move, or counterclockwise. So let's see if this works. And then we're going to do, start at math.pi, and we'll go to 0. So we're trying to draw this first half of the arc here. We'll see if this works. And counterclockwise, we'll go clockwise. We'll go ahead and do closed path. We're not done yet, but just so we can check this one. Sorry, I cough. Okay, so we'll close the path, and then we'll call just fill, and then we'll call stroke. And so that's how we draw with the path. So let's see, we should get a line. Okay, so kind of, sort of, maybe not really worked. So we ended up with this funny point here, and we also ended up with it. So let's do this to help us out real quick. Let's go ahead and draw this invisible box. Let's make it not so invisible. So let's do a, let's do temporary. We'll do fill style FOO, so that's red. And then we'll do fill rect, and we'll start with ball.x, ball.y, ball diameter twice. Okay, so this is making that invisible box not invisible. There we go. Okay, all right, so we kind of missed. So our first point was good. We could see we were where we expected to be, but then everything else is terrible. So let's see. So ball x, ball y. Diameter 2. That should be. I'll just go look it up. And it's done arcs in a while. Indiana. And if you're ever searching for something JavaScript related, slap MDN in front of it to get the Mozilla Developer Network, which is easily the best source for stuff on the web. Oh, you can actually do a full circle. Okay, good. Let's not do 4 points. Okay. Oh, and this needs to be the middle of the ball. That's why we're so screwy. So this is ball.x plus ball diameter divided by 2 plus 2. And let's go radius. We'll start at 0 and we'll end at times 2. Yeah, I was thinking about round chord. There we go. Now we're nice in there. Except we have this funny line here. And that's because I didn't start in the right place. Still have a funny one. Oh, yeah. We don't start in the middle. We start at 0. So, not divided by 2. Nope, that's one. Did they do false or true? It is 0 to pi. We can, so that line comes from when, I guess we just don't need to move to it. There we go. Yeah, I forgot to make a circle. Normally when I use arc, I'm using it around the corners, and that one's a little more complicated. You have to draw each line and stuff. I was overcomplicated in things, which is kind of common, and you want to watch out for. So, yeah, let's put that up because it's so long. Okay, so there we go. So now we got our ball, and we'll get rid of that red circle. We'll make it invisible. Okay, so there's the ball. Now we need to move the ball. So let's go just like move players. And we'll actually move balls first. Don't super matter, but just because. Move ball equals. Okay, so here now, so we have our ball is X and Y, and then we also, it has a velocity, so how much it's moving total in both directions, and then angle, what angle it's moving at. So to convert velocity and angle into a change in X and Y, we have to use a little bit of trick. So we basically just do ball.y plus equal ball.velocity times math.cosine ball.angle. And then similar, except instead of cosine, we use sine. And cosine and sine basically give us the X and Y like proportion, because math.cosine of an angle plus math.sine of an angle always equals 1. So that 1 times velocity means between these two, the ball is always going to move exactly velocity. And cosine gives us kind of the X portion of that movement, and sine gives us the Y portion. Unless I got them backwards, which may happen, but let's find out. Ooh, our ball disappeared. Oh, I forgot to multiply by delta. So we just moved it at 800 miles an hour. There we go. It moved down. So let's check out first what that random angle was we did on the ball. So 10.9. Okay. So none of those, well, yes, that angle, 4, yeah, I think we're half a pi off. Oh, we are half a pi off. That's 1 pi, so that would be half a pi. And then if we add 2 halves of a pi, next that's pi 1.5 pi, so 3.5 pi. I totally forgotten how radians work. There's a possibility. Let's go find out. Okay. Oh, yes, I did, because 2 pi is 360 degrees. Math's hard. Memory's hard. Yeah. Sorry, that is all wrong. So 1 pi is 180 degrees. 2 pi is 360. So that's half a pi. So yeah, that is a quarter pi. So then plus 90 degrees to get to this one would be 5 quarter pi, 9 quarter pi, and 13 quarter pi. So instead of doing times 2 in our little formula, we want to do times 4, and we want to also divide by 4. Let's try that. There we go. There we go. And then we ever get those two in this? That's kind of nice. We do. Interesting. Oh, actually, that is interesting because we had this 7, so that's a really small number. Yeah, we're flipping too many times. Because, let's see, so 13 quarters, yeah, because that's actually, yeah, that's too much. It should, oh, because it should be plus half a pi, not plus full pi. So it should be pi quarter, and then half a pi would be what, 3 pi, 5 pi? So the 2 is actually right. There we go, all 4 directions. Nice. Okay, so now we have that, and right now it's just going to go off, and it's going to keep going for infinity in that direction. So now we need to do collisions. So before, we did a point to rectangle collision when we figured out how to tell where we were clicking. So now we're going to do a rectangle to rectangle collision. Tell us 2 rectangles collide. So it's pretty similar of an idea. The difference, though, is we need to also check we also need to check. Sorry, it's late. Brain's fried. We need to check that. So we still need to check that they're that these things basically, and we're going to use that point. But then we also have like this direction. So really, the easiest way to check, is to calculate this this overlapped rectangle here. Because if this overlapped rectangle has a width greater than 0 and a height greater than 0, that means they hit. So to do that, we can basically take this point, or sorry, this point and this point, subtract them, and take the absolute value, and then take this point and this point and subtract the absolute values as well. Let's do that real quick, just to make sure. Type rectangle equation. Okay, so they're actually just doing the 1 point approach here. With the rectangle with the arrow keys. No collision. There's the test. If, let's see, if rectangle 1.x, so that would be, let's see, rectangle 1 is the red one, is less than this one plus its width. Okay. And then this rectangle plus its x is greater than this. Okay, yeah. Yeah, that makes sense. So, yeah, basically you're checking that this point is somewhere to the side of this edge, this point somewhere to the side of this edge, this point somewhere to the side of that one. Yeah. Yeah. Okay, so let's go ahead and let's just make a helper function for this. So we'll do, what will we call it? We'll call it, rect collision maybe. Rect collision equals rect1, rect2, or actually, whenever I have two things in the same, I like to call them just A and B just because it's easier to type out. Export default rect collision. But only in really isolated cases like this. If I wouldn't do this in like a main code body. Okay, and we're just going to return this. And I'm just going to swap out the all rect1 become A, and we'll just rect1 becomes A, rect2 becomes B, and I don't like to abbreviate width and height, so we're going to keep those. Okay. So now we have a helper function we can use for that. So, and then we also though have to check. First, we'll check is the ball hitting the edge. So checking the edge is pretty easy. We just check. So if this was the edge, we just check, and this is the ball's box around it. We check is the x or is the y plus height greater than the bottom of the edge, or is it y, if this was going up, is it y just negative, because 0 would be right at the top. So, so move ball. So we'll move it first, and then we'll check its position. So if ball.x is less than 0, or we'll do less than or equal to, so as soon as it touches the wall, we're going to do, we're going to change its velocity. So when you have reflect, or when you bounce something, if you ignore gravity, things bounce in a mirrored angle. So if we're moving, if we hit something and this angle is 45 degrees, then we're going to bounce off in a mirror where this is also 45 degrees. Or if this was 5 degrees, this would be 5 degrees. So we're going to do, all right, so ball dot angle equals, Oh man, I can't remember anything today. It's been too long since I built Pong. Um, let's go Google. Um, equation to reflect angle over x-axis. Reflect dot y is the same thing. Yeah. And answer to your edit, what you want is 180 minus 8. X breaks down to, yeah, math dot pi. So x minus 90 adjust angle so that 0 point is at 90, negating them to yeah. I think just negative angle should work too. Let's find out. Equals negative 5 angle. Let's see what happens. All right, so this is testing for the top, so we'll have to refresh until we get it moving up. Let's see what happens. Okay. Nope. All right, so let's double check first. Just did we get into log all hit top? And then console.log the new ball angle, and we'll log the old ball angle up here. Okay, so two. Okay, so it didn't console log anything, so it looks like it didn't work. And we'll check it. We do have a pipeline, or we don't have a pipeline. Oh, still I'm a goofball, and that's why. Nope, keep going right now. All right, so boop, boop. Ah, perfect. Okay, so let's check the other direction now. Of course, it won't come up. Come on. What do I need? I'm going to keep refreshing and miss it. Okay. Yep. Yep. It's there. Doo-doo. Okay. Good, cool. So that did work. Okay. So now, and actually, since it's that simple, we could just do or ball.y plus ball.height, or actually, that's ball diameter, is greater than or equal to height, which is just height of the canvas. So now it should work. It's all need to do. Okay. See a different one. Do. Go down there. That one, go down. Come on. There we go. Do. Go the last direction. Do. Awesome. Okay, so now we have the ball bouncing off the edges. So now let's make it so if it hits, or actually first we'll do the easy part. Let's do the score. So first let's go ahead, we'll render the score. So let's just into our options, we'll put score for each player, and we'll start at 0. And we need to render the score. So in our render function, we'll say draw score. We'll call this, well actually, we'll have one function draw both scores. Okay, that way it can position them appropriately. Okay, so we'll do, first let's set up style, so we'll do font. Let's try maybe 24 pixels, and we'll do the same Arial Helvetica sans serif stack. And then we'll do a fill style, we'll do an almost black, and then let's do a context, we'll do the text baseline from the top, so you can position them from the top. Let's say maybe just 4 pixels, we'll make it kind of close. And then that should be good. So now we'll do fill text, and we're just going to kind of wing things. So let's go width divided by 2 minus, I don't know, 50. So this will be back 50 pixels from the start line. And actually we'll do context.textLine equals right for this one. So that, and then context.textLine equals left. That way they're both the same distance from the center line. Okay, so text first. So player1.score. Then the X should be back from the edge or from the middle. Y will just do that should be top, and this should be 4. And then we don't need to match this. Okay, and then player 2, almost the same. We'll have the same Y. We're just going to do 50 from the center the other direction. All right, so let's see if that works first. Okay, so cool. Now we'll check if the ball hits one of the edges of the screen. We'll give a player a point, and then we need to reset the ball. So when we move the ball, so if ball dot x less than or equal to 0, and player 1 dot score plus plus, so increase it by 1, ball dot, and let's go ahead, we'll make a function called reset ball, because we're going to have to do that not a couple times, so reset ball. And then we're just going to here, we're going to move this stuff down there. And we're going to call reset ball right here. And then we're going to do ball dot velocity. That. Ball dot angle. So we'll just have it start going in random directions. Okay. So, okay. So and now, okay. And now we'll do reset ball. And then else, we'll do else if ball dot x is greater than or equal to width of the canvas minus ball dot x plus ball diameter is greater than or equal to the width. Then, whoops, I did this wrong. So this is hitting the player 1 side, so player 2 gets a point. And then this is player 2 side, so player 1 would get a point. Okay. Let's just watch what happens. Oh, except it didn't reset. It did bounce, though. I don't actually know why it's bouncing because how did I do that soon? Reset ball. It's increasing the score. Some glitched, and now the ball's permanently on that side. It doesn't look like reset ball is quite doing what it's supposed to do. Oh, so I forgot to set the ball X and Y. So actually, we're going to move this whole thing down here. Yeah, that's why. So we were reassigning it a velocity each time, and it just coincidentally looked like the ball was bouncing off the wall, but really it was just moving back. And then when it went infinite, that's because it just happened to bounce the way that kept it going off the screen. So we need to reset all of these things. Whoops, and I have a syntax error somewhere else. No, just it all. Now that. There we go. Okay, cool. Real quick, undo I put that blue because we don't need that anymore. Okay, so now we have it so it can score, it can get to the field. Now we want to make it so if the ball hits the paddle, we want to bounce it off as well. So let's go ahead do create game. So here's where that right collision will come. So okay. So we can just kind of chain all these together because we'd only ever do one of these. So if it's hit the top or bottom, we do that. If it's hit the left or right, we score. Else, if there's a rectangle collision between player 1 and ball, and this won't quite work yet because we need to go pop in width and height into those. Player 2 ball. Okay, so let's go ahead and give this a width and height. And we'll just put it right in here. We'll still paddle with. There we go. We'll still keep the constant so we can still fiddle with them. We'll put them in here too. That way this object works as a rectangle for functions. Height. height. There we go. And we'll do the same for ball, ball diameter, height, ball diameter. Let's go ahead real quick and update our code everywhere we use those. Let's just use we're not passing in paddle here, so we'll leave that one alone for now. We will change these though. And we'll change should be we'll leave those two actually. We'll change this one. All about with okay, you know what? Let's change that bugs me, so let's change this. We'll pass in a paddle, which is paddle.x, paddle.y, paddle.width, paddle.height, and then instead of passing in the x and 1, we'll just pass in the whole path, the whole player. And then let me decide how much this one does. This one, I don't love it organally. No, it really doesn't. So we'll pass in. Oh, you know what though? Because now we have an object, let's just pass in the paddle and we'll get the velocity and the y off the paddle. That'll work. Actually, not undo all that stuff. And we'll destructure it off of it, so we don't have to have that a million billion times. And we can also get height off of it. And because we have canvas height already defined, we're going to do a colon and call it paddle height, so we can differentiate it. And we'll do these as a let, so velocities can be updated and the y's because we're changing those, and then we return them, and we'll still assign them back like we did before. Or do we do that? New player, new values. Let's actually we'll pass in the player, and we'll just have this function change it. We'll do update movement, and then we don't have to do this. And then down here, instead of returning, function to match, update movement. Down here, we'll do that same assignment. Paddle, and then velocity and y. Okay, there we go. That's better. Now we're using that height, width, and height assigned to all those. So if we ever you could maybe implement a power up where a player's paddle gets bigger, or maybe it creates a handicap where if a player is losing, their paddle gets proportionally bigger, something. So now that would be easier to implement because you just update that value and everything else that go along with it. So now, you guys have joined. So now we're back here. So now these are fully fleshed out rectangles, so we should be able to tell here. So let's just say player 1 hit, and we'll go check to see if we're hitting. 2 hit. Okay. And so now nothing will visually happen, but we should get a, if we do manage to hit, we'll get a, look at that, player 1 hit. And it hit a whole bunch of times because it hit for each tick while the ball was moving on top of it, which is okay for now because we'll bounce them off. And then player 2 hit. So yay, that works. Okay, so now, if it hits player 1, see, are we going to get lucky? Does that work? Find out ball. I don't remember. Let's see if it works on X. Yeah, I didn't think so. Oh, what was that? Looks like, See how we're hitting the bottom of the screen and it's jumping all the way up. What's that? Right to that? Alright, let's fix that real quick. Interesting. Doesn't happen when we go up, though. It happens when we go down. Curious. So let's go look. So that's where the clamping stuff was. So let's update movement before we update the paddle. Actually, I better rename this to update paddle. Okay, so our Y. We're clamping to a min of 1 and a max of height minus paddle height. That looks right. So let's go see. Is this wrong? So let's see. So in this case, our value would be like, say our max was 600, and our Y was like 700. What would happen? So we would have mouse.min 600, mouse.max 700, and then 0. So this bit, the max between these two would be 700, and then between these two would be 600, which would be correct. Although I did just realize we may not have. Maybe we do. No, we do have that. So we do subtract the paddle height, so that's right. And then, oh, wait, what's this y equals 0? That's not right. If y equals 0, y equals height minus paddle height. I don't even know if this was supposed to be. I think, did we have that before we clamped maybe? I don't think we need that at all anymore. Let's see. Alright, so let's check player. Good. 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 Okay, so that works. Now let's back to the ball. Okay, so so it doesn't reflect right on that. So we need to. It's actually, you can kind of see it's. So if it's moving up, it kind of zigzags back and forth like this, but it keeps moving that way. So we need to make it move that way. So I think if we is it just minus math.pi maybe? Yeah. Kind of works. We're going to have to adjust it so if the ball's overlapping it a bit, we need to shove it off, so or else it'll collide like 10 times and do that weird zigzag thing. So let's just get it working in this basic form first. So minus 180 might have actually done the trick. Oh, yep. Okay. I haven't totally forgotten everything ever. Doop, doop, doop. Okay, so that's good. So now let's just do one little bit where we shove over the ball so that if it is overlapping a little bit, it's going to not keep overlapping. Because depending, you might have a rounding error, so sometimes it might not happen because like you'll be 0.3 over and it won't matter. But sometimes you'll be like 0.9 over and it might matter. So we're just going to nudge it over. So we'll nudge its x over. And we'll just do player1.x. So player 1, to get the right edge, we need the player 1's x, and we need to add witness to it. So player 1x plus player 1 dot. And then just to make sure it can't possibly be right perfect with it, we're just going to add 0.1 to it, just to nudge it over just a teeny tiny bit so it's not actually right on it. And then same thing here for player 2, except we're going to, x is already the left side, which is what we need for player 2. So we're just going to do that, and we're going to minus by the tiny bit instead of adding. All right, so let's see. All right, that didn't work. All right, let's see about here. Oh, so it didn't work on player 2 because we also need to adjust for the ball. width. And also, you just saw we got a little up at the top for a similar reason as the paddle. So when we bounce off the top and bottom, let's nudge the ball as well. So this would be minus ball dot width. So we shove it over to make sure that the right edge of the ball and the left edge of the player, which I think shows you guys backwards, so that's confusing. Okay, so bump, bump, yay. Bump, 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 bump. All right, you know what? To make testing faster and to test my Pong skills, let's ratchet some things up. We're going to double all these numbers to make it go faster. Okay. Bump, 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 bump. All right, we're looking pretty good now. Okay. All right. I'm going to leave it at that speed for now. Okay, so let's go real quick. Let's fix that at the top bit. So we're going to do, we have to nudge it slightly different ways. So let's go ahead and we'll just split these guys. Well, yeah, we'll do a nested if. So I think and actually I want to do the same thing down there. So let's do ball.y is less than or equal to 0. So if we're touching the top, we're going to do ball.y equals, and we're going to do 0 plus 0.1, which is just 0.1. Else, that means we have to be hitting the bottom, so we're going to do height minus ball height minus 0.1. I think height is the #1 misspelled word in my programming career by like far. Okay, so here let's do the same thing. So we'll do, we'll do else here, and we'll get the player collisions and stash in the variable. Player 1 ball, player 2 collision, player 2 ball. And then we'll check if player 1 collision or player 2 collision. That helped me. Okay, and then we'll do the angle bit, so equal minus ball dot angle minus dash dot pi, and then we'll do if player 1 collision, we'll nudge it this way. Otherwise, it has to be player 2 we're hitting, so we'll do that. Okay. So that's it. All right. Dun, 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 dun. Nope. All right, let's check it on there. Okay, so I think we're pretty good now. Okay, so let's slow things back a bit because that is kind of hard. But one thing we want to do to make it interesting, so there's a couple of different ways I've seen how you kind of handle the angle of the ball and how fast the ball moves. So technically, like pure physics, no matter where I hit on the, if the ball hit the paddle and the paddle wasn't moving, no matter where it hit on the paddle, it always reflects off of the same angle, which is an exact mirror, which is what we have. Now, if the paddle were moving in real life physics, if the paddle was moving, that would actually affect the angle that it bounces off, because some of that velocity gets transferred to the ball, so it bounces off a little bit. So that's one way you can kind of do the paddle, or to like get the ball so it's not always only a 45-degree angle. Another way I've seen it, and that's kind of the most physicsy way, although that's not actually the kind of classic way. I think the more classic way is actually, depending where it hits on the paddle, affects what angle the ball goes off. So like the closer to center it is, if like you hit dead center, it bounces off at the same exact angle. If you're on one of the edges, it'll bounce off at kind of a skewed angle. So I think that's how we'll go ahead and do it. And let's also make it so, and the ball speed changing also I've seen in different ways. Let's go ahead and we'll make it so every time the ball bounces off of something, it speeds up just a little bit more, which is completely backwards from real life physics, but it'll make it more interesting. That way, the longer the match goes on, the higher the tension, because each time it hits something, the ball's going to move. And we'll only do it if it hits the player's paddle, so that way you can kind of get a nice volley going. Um, so that's two things we want to do. Let's go ahead. We'll do the speed up first because that's the easy part. So we'll just say, so here's where we've hit the paddle. We'll just up the velocity by, let's create a constant because we like to have numbers we can fiddle with all in one place. We'll do ball acceleration, and in this case it's not going to be per second or anything. It's just going to be a flat per paddle hit. So each time we hit the paddle, we'll increase it by 10 pixels a second. So plus equals ball acceleration. Okay. Let's see how that looks. And you know what? For testing purposes of this, let's make our paddles gigantic. We're going to put on the training wheels and go easy mode. We're going to have 580 pixel high paddles for there we go. Easy mode. Whoops, sorry guys. No. There we go. All right, easy mode. So I made our paddle really tall so we can see the ball speeding up. So all right, so it's a little subtle at 10 pixels. That means we'd have to really, bounce it probably 40 times to get going. Let's maybe say 50. Let's see if that's too much. I think probably the kind of nice number of bounces before you get too tensiony is maybe about, 6. So that's 2 bounces, 3. And we're not going to put an upper limit on this. So if you had like 2 just, gods with Pong, this thing may be going 100 miles an hour. That would be death ball at that point. All right, there we go. So that's pretty good. By the time you get to this number of bounces, you kind of want one player to lose because it's been a long volley. So, okay, so I like that. So we'll stick with 50. And then, so that's our speeding up bit. And now let's take it back off easy mode. We'll put that 60, a little taller than we were before. Or what were we at? 60? I don't remember. Yeah, we were. Okay. Let's actually go 80. We'll make them just a smidgen taller. Okay. Now let's do the whole angle thing. So what we'll do here, we'll reverse the angle, minus it by pi. So before we reverse the angle, we want to, how do we want to do this? Let's say, so let's first get we'll call it, paddle offset maybe. I can't think of a great word, but try to use it. But this will be we'll make this a number between -1 and 1, where 0 would be hitting the dead center of the paddle. -1 would be hitting the very top of the paddle. -1 would be hitting the bottom of the paddle. And so we're just going to basically compare. So if this was our paddle and this was our ball, we're going to compare where this point hit. So if it was right there, it'd be 0. If it was right there, it'd be 1. If it was here, it'd be 2. So first, we'll just get the overall difference. So we're going to just basically do move this down here. Because the paddle, we have to calculate the paddle offset per player, and we only know per player which player hit right there. So we'll do a let paddle offset here. All right, and then paddle offset for player 1 would be player 1 dot y. That's the top of the paddle, plus player 1 dot height. That's the bottom of the paddle. And then, okay, let's draw this always handy to have paper when you're coding if you need to think through something. Scribbling something tends to be easier. Okay, so let's say, let's just put some numbers to this. So like, say that the paddle's at like 400, and so 480 would be the bottom. And so if the ball was at 440, that would be, and so first we're going to calculate just a number between 0 and 1, and then we'll shift it later. So that would mean that 440 would be E to D. So if we take the height, or the, let's see, so the overall size minus the Y, that gives us 80. And then if we take, so we could subtract this 400 from here as well. 440 minus 400 equals 40, and then we just divide those. So if we put this in like variable terms, we're going to call this, we'll call this bottom. So we'll use B for bottom, T for top, and then this will be ball, and we'll just call that Y since we already used B. Okay, so, and B equals T plus H. Okay, so this would be, actually, we don't even need B then. Let's just do T plus H. So T plus H minus T. So that's this part. I draw everything at an angle. All right, T plus H minus T. That's the bottom. And then up here, we have the ball's Y minus H. And just those. Okay, and then we can, so, and program read terms, that would be like this. T plus H minus T. And then can we simplify that at all? What would that be? And sometimes simplifying is good. Sometimes simplifying just makes it more confusing to read. But I feel like there's a simplification we can do here. Oh wait, sorry, I had a little fruit fly or something on my screen. You know what? Let's not worry about simplifying it right now, because actually we can simplify this part, because this part we want the 80. Well, the 80 is just the height. So really, it's just Y minus, oh, and this is T, not H. So it's really Y minus T divided by height. Yeah, so that should work. Okay, so then, what did we say? We said ball Y, ball.Y, and we want the center point of the ball, which, so here's our ball. Y is actually, remember, this point of the invisible box. So we actually want Y plus half of its height, for Y height divided by 2. That's the middle of the ball. Minus T, which is really player.Y, divide by, divide by the height of the paddle. Okay, let's go ahead. We'll just console log that just so we can take a peek at it. Should be a number between 0 and 1. Let's find out. Okay, so we got it pretty close to 0.5, which would indicate the middle. Come back this way, ball. Okay, so let's try to hit it kind of at the top. Okay, so that's pretty good. That's a pretty small number. And then we'll try to hit it on near the bottom and make sure it's about 1. Okay, pretty good because I did hit about 3/4 of the way down. So cool. So it looks like it's working. Now let's go ahead and make a helper function. So we now have a number between 0 and 1. So now we want to actually go from 1 to 1, and 0 would be in the middle. So we call this scaling, basically. We scale the number from one range to another. So, and to scale, we basically go, so really, if we're going -1 to 1, our height is 1. It's a scale and then it's a shift. So first we scale it up to a total height of 2, whereas this is a total height of 1. This one's 1 height, 0 to 1. So we scale it up to 2, and then we shift it back by 1. So really that means we have, so our min is 1, our max is 1, our min is -1. Total size is 2. So we would multiply this by 2, so 2 times, we'll just call that v, and then minus min. And this 2 is max minus min. So it's max minus 2 times v minus min. And that's how we can scale and shift between any two sets of numbers. So let's make a helper function for that. So we'll call it scale and shift. All right. We'll just call it scale. Scale value. Scale value equals value min, or we'll just say that incoming value has to be between, value must be between 0 and 1. And we could have, if we needed it, we could have a paired function with this normalize, which would basically do the opposite. It would take two numbers and put them between 0 and 1. So we'll just do the scale part for now. Okay, and then we're just going to do that math that we just had. So we get kind of the overall height first by figuring out max minus min. Then we times that by value, and then we subtract min. And technically order of operations says I don't need to wrap this in parentheses here because multiplication would go first. But just for readability, it's nice to go ahead and do that. So that should work there. And we'll export default scale value. And then over here, okay, so we have our paddle offset. We're just going to wrap this in scale value. And -1 and 1. Okay, and then we'll do the same down here, and we'll just use clear 2. And we need to import scale value. Okay, so we have a paddle offset now. So let's go ahead, we'll just output this to make sure it looks right. So now we should have a number between -1 and 1. So that's not 1. We did nothing. Okay. Let's see. Yeah. Okay. Oh, plus, not minus. That's the problem. And because min is a negative in this case, I ended up adding to it. But it should be plus min because we're shifting it to whatever min is. All right. Okay, so that was almost 0. That's what we expected. Oops, I missed. Try to hit it. Oh. Okay, so that was pretty close to the middle, so that's good. That was pretty close. Or wait, no, yeah. Player 2 was not close to the middle. Okay. Try to hit the bottom. There we go. Okay. Whoop, we're over 1 still. All right, something's still a little wonky. No, come back. All right, so that might be about right. Okay, that was pretty close to what we want. I missed. I'm going to try to hit it right on top. Nope. Okay. That was almost a perfect number. And that's too big. How are we bigger than 1? That's curious. That was bigger than 1. Oh, you know what? Yeah, that makes sense actually um, because we're using the middle of the ball. No, that still doesn't. Yeah, it does. Because the ball could technically hit like, and we're not going to try to fix this just for this because it's getting a little nitty gritty for what we're trying to accomplish. But so we have the ball here, but remember the ball has like this invisible thing. So if the paddle's here, the paddle could like technically nick. So this is the middle. The ball could technically nick like the top of it, so it can go slightly over one. And on the flip side, it could slightly go below -1 as well. Well, that's okay. We have a good enough value. Now what we're going to do with that value is we're just going to use that to shift the angle a bit before we reflect it. That way we'll kind of end up skewing it, but in a kind of predictable way. So we'll do plus paddle offset times, and then just some numbers. So let's say maybe pi divided by 6, so that would be about 15 degrees. So that means we could add or remove about 15 degrees from the hit, in theory. So let's see. Oops, oops. Okay, so there we go. So that kind of sent it up. Oops. Will that come up? I just remembered in Commander Keen, which is a really old game now. It had like a Pong built in. It's been time, and I remember it was very easy to make it like end up zigzagging back and forth, so it bounced like a billion times before it got back to the other side. It was kind of buggy like that. We'll leave that because now I'm all nostalgic. Yeah, so that's pretty good. Except let's go ahead. We will change the bit where it increases speed. We will change it instead of just increasing speed when we hit the player's paddle. We'll go ahead and we'll always increase speed if we hit anything, including the wall. So we're just going to do this a couple times. So not if we hit the edge, but if we hit the top or bottom as well. Because and the left and right we reset. So this will get it going faster. But now 50 is too much because it'll be like crazy before it makes it to the second player. Okay, so let's see. Boop. Boop. A little faster. Boop. Kind of crazy angle. Boop. It should speed it up real good before it gets to player 2. Boop. 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 Alright, with that kind of crazy angle going. Boop. 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 Okay. All right, so I think that's good enough. If you wanted to download this and play with it yourself, and tweak the rules a bit, you can. But I think we're trying to learn how to build games, so we don't want to spend too terribly long in the nitty gritty. At this point, it's just kind of fiddling with numbers and kind of improving the flow. But yeah, we will go ahead though. Let's. I kind of want to get rid of that outline because it kind of deceives where the ball is. So let's change how we draw the ball. Let's no longer stroke, and instead we'll just fill with like, I don't know, kind of a medium gray maybe. Kind of medium light gray, so that can be too light. Let's find out. It's not bad, although it has like a weird extra bit on it. I'm not sure where that's coming from. So, huh. Let's stop the ball from moving for just a sec. Look at that closer. So to stop the ball, I just returned in our move ball, so we never actually run it. Oh, okay. It may just be an artifact of moving in that color. That's weird. That doesn't seem true, though, because maybe. Oh, yeah, I guess it is kind of an artifact. It may not even be showing up in the video, but we also get that artifact on the paddles too. I didn't even notice that. Interesting. Like an unintentional motion blur. We could do a double buffered canvas to get rid of that, but we're not going to implement that right now. Okay. Okay, and let's just draw a background on the field so it's not so blindingly white. Draw background. And so the background's real easy. We're just going to fill in a rectangle for the whole screen. Context, fill style. Let's go dark mode. Do 333. That's a pretty dark gray. Although that's actually the same color we're using our score, so we'll have to go change our score color. And 0, with height, we'll fill in the whole. Again, fill in the whole background. Okay. That's not too bad style-wise. And now let's just change the color on our score. So we'll go light with this. We'll go FO, which is almost white, but not quite. Okay, so let's go back here. We'll put this back on start screen. So now we have our start screen, and actually let's go fill in our start screen with the background too, because now it's really glaring. Background, and I'm just going to copy and paste that same one, which isn't technically dry, but sometimes you want to purposely not be dry, and this is one of those cases. And the reason for that is because even though they have the same code, they basically have the same code by coincidence. Like there's nothing relating them directly together. So we don't really want them to be dry in this case because one may change and we don't want the other to change. So the same by coincidence, it's okay to break the dry rule because when you're dry like they're the same for the same reason, not they just happen to coincidentally look the same. And we're getting yelled at because we didn't do structure height. So let's do structure height. And I'm going to rename, since we used draw on the other one, I'm going to rename these to draw. I'm still going to keep the one render, but I'm going to call these draw still. Just for consistency. Consistency is good. My cat's like asleep against the corner, the back of the door, and every so often he hits the back of the door, so it closes just a little bit more before we're done. He's probably going to have the door closed. Okay, so refresh. Oops, that didn't work. Draw background. Direct, draw background. I have a typo. Refresh. Put in just a random console log to see if it shows it. Yeah, up there. Okay, that was weird. I don't know why it didn't refresh. Okay. Okay, so we got that now. We got the game going. So now, let's go back to our first diagram. Now we just have one thing left. We have the game over screen. So it's pretty straightforward, really. And it's actually, aside from the extra bit of text here, it's actually basically identical to the start screen. So why don't we go ahead, we'll just copy the start screen. And again, this is another one of those places where they're going to be coincidentally the same code. So we're not going to worry about dry because they're not the same code on purpose. So copy that. I just need to call this game over. Okay, and we will tweak something. So let's go ahead for now. My IDE is yelling at me for not being dry. Duplicate code fragment. So let's go to create game, and we'll do inside of max score. So this will be the value we have to go to change screens. We'll ultimately make it 10 or something, but for testing purposes, let's just make it 1 so we can move on right away so we can see if it works. And then here where we add to the score, or actually we'll do it down here. Sorry. Bouncing all over the place. So we don't want it to move ball because it doesn't actually have anything to do with moving the ball. We'll do it down at the bottom of the tick. If player1.score is greater than or equal to max score. And technically, it should never be greater than max score because we should move with equal. But when it kind of doesn't matter, it's good to always do greater than or less than. That way, if some magical way you do end up outside beyond the range, like if we did manage to skip right over max score and keep going, we could go for infinity. So by doing greater than, we stop that, because like you may, down the line be like, you may implement a double score or something. And if you implement a double score and you forgot to update this, you may jump right over the max score. And then you have an unwinnable game because it'll just go for infinity. So putting a greater than or less than on something that you probably won't go over, but even if you did go over, you want to move on, is usually a good idea. So player one score is too high. We're going to use Scene Manager to change the scene. And we're going to go to Game Over. And I just realized we made those string constants, but I can't use those from here. So in just a second, we're going to move them. And we'll just do, or player two score is greater than or equal to max score. And so that'll change, but we want to be able to display who won. Right now, we don't have a way for scenes to directly talk to one another. So let's go ahead, let's add a data manager. And just like the scene manager manages scenes, the data manager is going to manage data. And we're also going to make it a singleton as well. And it's just going, and by data in this case, we're just going to have arbitrary bits of data that we can add and read out. That may be whatever. So we'll just call it add. And this will be, we call it key and value. Actually, let's call it set, because if you call it and you've already used that key, you're going to override it. And get. And we'll just return that value. And then, because we're doing a singleton, we're not going to export the class. We're going to make an instance of the class. And then we're going to export just that instance. So it's effectively a singleton. And now what we can do in our game screen, before we switch over, we're going to call data manager dot set, and we'll call it winner. And we'll do player one dot score greater than equal to max score. It'll be player one, and we'll just put the exact text we're going to show over there. So right like that. And then now we'll be able to read that on the game over screen. But real quick, let's go ahead and we'll put these strings and constants. So the scenes we already have, let's just move this out. We'll make a constant file. And we could make one for each, but usually if I only have a couple constants in the program, I'll just lump them all together. And then instead of doing a default export, I'm just going to put the word export here. And then when I import them, it's a little bit different. So you see how all of these don't have curly brackets, and this one does. So default exports, really these can be named anything, and you don't put curly brackets. If it's named one, you must use this name, and you can change it. I can say like add cookies or something to change it, but I don't want to. And they go in curly brackets, and you can have multiples of these in one, which we'll see in just a second. So there's that, and let's do another for data keys. We'll do winner. Okay, and now let's pop over to start screen first, because I remember we used scene in here. Game. Let's do scene.game. Okay, and then we'll go into game. We'll do scene.gameover. And here we'll do data keys.winner. And now you can see here I have two different imports, so I imported both those. And you can have a default export too. So if I had a default export, I would do it like this, where the one's outside and then the not default exports are inside. Okay, so now let's go do game over. So first we'll update this because we copy pasted all this code. So scenes.game it still. Okay, so now let's see what we need to change. So let's just call this button that in both of these, because we only have one button each. So we'll call this file button. and then we'll call this matrix. Okay, now let's go do the same thing over here. And see, my IDE is a bit mad at me because I'm duplicating code. But like I said, in this case, it's okay because it's only the same by coincidence. And some of it we could try. Like we could pull like creating events and checking events or checking buttons into its own code and stuff, which maybe we will. In fact, so let's finish up what we're doing. Okay, so we're going to do draw. We'll rename this draw game over. And call this game over. Game over. Game over. Okay, and then our start button, instead of saying start, it's going to say play again. And actually, you know what? Let's put title over button. Don't like to repeat strings when it programmatically matters that they match. So we'll make them not match, or we'll make them variables. Actually, they're identical at this point, so we're just going to cheat and copy paste and copy back there. Okay, so and start on title equals Pong. Okay, and it's yelling at me, so I duplicate code, and that's it for now. So let's just Pong. Oh, our we had a stroke around here, but now the stroke's the same color, so let's go make the stroke white real quick on both of them. Or not exactly white, we'll do a light and almost white. Okay, there we go. Okay, so let's get our first score. We should go game over. Yay! Okay, so now basically the only change on here we need is we want to show which player won. So let's go to, actually before that, let's go ahead, we'll dry these up a bit. So let's make a couple helper functions. Let's make a, we'll make a draw text function. And we'll do draw text. And that needs to take a context, the text, let's say the X, Y, the color, and then we'll have fill and stroke, which will be booleans. And we'll say fill is true by default and stroke is false by default. Okay, and then on here then, for our text, I changed my mind. It's hard to generify these in a way that's reusable, and we could make like a draw title thing, but that's kind of a too specific one to really do, so I'm okay with these bits not being dry. Yeah, we'll just have the IDE yell at me for a bit. So we'll do draw winner, and then we'll do const draw winner. Cool. And then let's see, we'll copy paste this just to cheat a bit. Let's not stroke this because it'll just be too busy, I think. Let's not fill it blue since we're not stroking. We'll just fill it a light color. Let's shrink it down. So let's see, that's 120. Our button is 60, so maybe the middle, go 80, middle-ish. Maybe we'll actually do a middle. So let's go 80 bit. And we'll drop this down. So let's see, that's aligned to the top, so it's about 150 plus the height's 120, so its bottom is 270-ish. So let's try 300 maybe. Let's try those. Oh, and let's go ahead, save ourselves some hassle, and we'll just we'll go ahead and hop over right to game over. Okay, so that was a little cramped. Let's move it up a bit. Game over. Let's try 270. Or try. 270 is actually probably not too bad. And we'll go ahead and change this text here. And this text doesn't need to be repeated, so we'll only do it once. And we're going to read out from the data manager the winner. Data winner. So blah blah blah. So how do you say player 1 or player 2 wins? Have to do the exclamation mark. Undefined wins, yay! Oh, because we're cheating and we're jumping scenes, so we'll cheat a little bit more temporarily, and we'll just set winner. I'm just gonna type it out. Winner. Let's say player 3 to remind ourselves to change it back. There we go. Okay, let's knock it down to 10 pixels. So 280. Okay, there we go. That looks pretty good. We'll hit play again, and we'll come back here. All right, so now let's uncheat and start at the start screen. Let me get rid of the unnecessary import from that cheating. And then let's go, and we'll set this back to a proper number, 10. Okay. Now time to, we'll see, let whoever wants to play a little bit. Let's see. Bounce, bounce, bounce. Should angle up more, should bounce, should move. Ooh, that was an interesting bounce. And yeah, it's not super predictable or perfect, it's kind of changed, but it was good enough. Nope, player 2 has a pretty big lead. Player 1 can come back. Oh, the mountain's been pretty stable now. Oh, there we go. There. This is going to be slow for a bit, but every one of those bounces speeds it up. So let's see how fast it's going here. All right, let's start trekking. Ah, it got faster than I could move. Okay. And player 2 is dominating. All right. I don't know. I'm like focused on player 2, and then I'm like, oh, the ball's moving towards player 1. I should move it, and then I just kind of watch the ball. All right. Focus on player 2. Let's see if it can make it come back. For player 1. See, even when I say I'm focused on player 2. Oh, no. Okay, I'm really not trying to let player 2 win on purpose, but or maybe subconsciously I am. Alright. Alright, so it's looking pretty good. Not too bad for what? How long have we been streaming? 4 hours? Yeah. Alright, let's just let it end itself. Okay. Yay, game over, player 2 wins. So when we hit play again, we want to make sure everything resets. Look at that, 0, 0, things are back in the middle. Awesome. I think we're done. All right, so that was Pong. So let's go ahead, before we end the stream, I'll go ahead and get it uploaded to the GitHub repo. So let's go make a new repo. New repo. So we'll call this Pong. Pong game, we made a string. Create repo. And then I'll copy this. So because I cloned the basic web template repo, we need to, its origin is still set to that, so we need to remove that origin. And then git remote add origin, we add the new origin. And then we do git add dot to add everything, we do git commit -m built Pong. Status to make sure we're clean, that's good. I'll git push to origin master. There it is. So if you want to download Pong and play with it yourself, there's the code for it on the repo. If you enjoyed the stream, be sure to follow so you can get notifications when I'm streaming again. Trying to work out a kind of a regular schedule. I'm thinking it may be like Thursday, Friday, Tuesday or something, with some extra streams thrown in, but not quite sure just yet, so I'm not going to schedule a stream just yet. But follow and you can get notifications when I do start the stream. If you follow me on Twitter, I'll try to announce them as soon as I know I'm going to do a stream that day. I'll try to announce on Twitter that I'm going to do one later, and I'll so you can hit it. If you have any questions, you just want to chat, hit me up on our Discord channel. If you want to rewatch these videos, the recent ones will of course be up on Twitch itself for a while. I'll also put up a edited, more tutorial style version of this video up on YouTube, so you can check that out, anytime if you want to review this and stuff. And if you have any ideas for things you'd like me to cover, whether they're project ideas like this, or whether you'd like me to cover, some other topic or something, use any of those communication methods to reach out to me. Let me know. I'd love to do, stuff you guys are interested in. And yeah, thanks for joining me. So I'll see you guys next time. See ya.